Did you know that most routers are just a computer? Stick around, we'll show you how to turn your Linux machine into a router.
You're watching IT Pro TV.
Welcome back. We're here with more LPIC 2, and today is all about IP tables. Don, can you give us an overview of what we'll be talking about?
Sure. IP tables is an integral part of most Linux distros that allows for us to do a lot of crazy things like firewalls and routers and filtering, proxy, just really all sorts of amazing stuff. But in this episode, we're going to focus on the routing piece. So we'll learn about what's involved with configuring our Linux server to become a router, and we'll go through that configuration process with IP tables, and by the end of the episode, we'll have built a Linux router.
Now, why would we use IP tables as opposed to a dedicated router?
All right, so you can go really to any commercial store like Best Buy and buy a router right now and be up and running in a matter of minutes. Or if you're in an enterprise environment, you're carrying tons and tons of traffic, you can go and buy a Cisco or Juniper router and again, deploy it and off you go. But in all of those situations, you're really constrained to what that vendor allows you to do. And there's usually licensing agreements and it's fairly expensive. But at the end of the day, what you're buying is really just a computer. It's a very locked down and restricted computer. So if we want, we can build our own router. We can take any computer, any virtual machine that's running Linux and convert it into a router. And from there, it's up to us what features we want to support. IP tables in particular supports a lot of really cool things. It can be a straight up high performance router. Or it can be a firewall. It can be a NAT router. We can do port forwarding. We can do all the various things that we do in a normal router. We might not have a fancy graphical user interface or a web page where we just check boxes. Here it's going to be done in the command line, but we have total control over everything about it. We can do updates, and because it's Linux, it's license free. We can bring up a router like this and run it forever. We can use old hardware for our router. So there's a number of different scenarios where it'd be really beneficial. It's also useful for doing things like redirecting traffic. If we've got servers that we don't want exposed to the internet, we can use Linux as like a bastion host that sits in between, kind of like a proxy, that sits in between our internal protected machines and the outside world, and our Linux servers then protecting those resources. So a ton of different scenarios that are available there, and just it really boils down to power.
Now, normally I think of IP tables as a firewall. So can it be a firewall and a router at the same time?
It can, right? So a firewall is a router. So not every router is a firewall, but every firewall is a router. A firewall is moving traffic from one interface to another. That's exactly what a router does. The difference is a firewall filters traffic, right? So a firewall might block certain things and allow other things in. If we configure a true router doesn't block anything unless it has a bad address. Anything with a good address is going to get routed from one interface to another to move it along towards its destination. And so when we configure IP tables, if we don't put any filter rules on it, it is effectively a router. But the moment we put the first filter rule on there, now it's a firewall as well. And it's not like we have to install additional software or do any crazy configuration. It's just you throw the rule in, all of a sudden there it is. So it's really easy. It's all the same system, and it goes back to that idea of we have so much power available inside of it. Now, IP tables in its default configuration on many distros is set up as a firewall. So IP tables is like the standard routing package that's found in most Linux distros, and a lot of times it is installed by default. But it's not exactly easy to use. So a lot of end users aren't really happy with it. Admins can kind of get frustrated with it sometimes. And so many distros will either stick on a front end of some sort. So like in Ubuntu is running IP tables by default, but it has UFW, the uncomplicated firewall. That's installed by default as well, and it sits on top of IP tables. UFW is just a front end for IP tables. So it makes it easier for you to issue commands against it. And there's several other alternatives to UFW. If you're in the Red Hat world, well, they rely on systemd and firewalld to do a lot of their firewalling. And so that's a different service altogether. And that service can conflict with IP tables. So usually if you have firewalld, you don't have IP tables in place. So if we're going to build up a router, we might have to remove that other firewall first so that we don't have a conflict. You don't want to have like multiple firewalls on your system, that just creates a complexity nightmare and is a real challenge. And you can even bump into that with some of the front ends, like with UFW, where it doesn't show you every IP table's rule. You could be allowing traffic and not even know it because UFW doesn't show that. If you ever do a Google search for Docker foot gun, that Docker is really guilty of this. It will open up all sorts of ports in IP tables and you won't see it in UFW. So it's a good idea to get rid of the other stuff. If you've got UFW or Firewall D or whatever, uninstall those. Remove those from your system before you start working with IP tables and getting it built up. So here, just as an example, on my Ubuntu box, I'll do a quick sudo UFW status, and I can see that I am running UFW. I'm also running IP tables, although I don't really see that here. This is integrated with it. If I do a sudo IP tables-save, that will show me my IP tables configuration, and I see all these configuration lines, and a lot of them start with UFW, and I can see each of those entries in here. Here's the UFW entry that's allowing SSH through, but there's a lot more that's in here outside of that. So I don't want to get kind of tricked and have a situation where I don't know all of my rules. So I'm just going to do a quick sudo UFW disable, and then I'll follow that up with a sudo apt remove UFW. I'm just going to uninstall UFW altogether, and I'm now going to do all of my work in IP tables. I really recommend people do that.
So now that we don't have UFW, are we ready to configure IP tables?
We are, and actually IP tables is already running on the system. I didn't even have to install it, so I could just start configuring it and off I go. But there is a bit of a problem with IP tables default configuration. If it's already installed, or if you just installed it, right? I could do a sudo apt install IP tables. Once it's installed, IP tables configuration is ephemeral. And what that means is it's not saved to disk. If I reboot or if I restart the IP table service, it loses every change that I've made to it. And so that's not ideal, not usually. Well, what happens is like the configuration is usually fed from somewhere else. If I have UFW, it's feeding configuration over. And as other services like Docker start, they start adding to the configuration. And so we have a dynamic configuration. So if that's what you want, yeah, you're good to go. You can start to configure it. But I normally go a step further and get it set up for a persistent configuration. So it's a little bit extra that I need to do to get this kind of in place. So to do that, when we do an install, I'm going to do just real quick a sudo apt list IP tables star. So I'm pulling up a list of the packages that start with IP tables, and you'll see a few things in there. There's the main package IP tables right here, and then there's another package called IP tables persistent. That is IP tables that reads its configuration from disk. And so if we're going to be setting this up and going long term, we normally want that installed. And if I look at it here, see how it's not installed for me? It was automatically installed for IP tables, but not for the persistent version. So I'm going to do a sudo apt install IP tables-persistent, and that's going to install that extra package. If IP tables wasn't already installed, this would install it as well. So it's kind of like a one command we can use to install IP tables. Once we do that, it's going to ask, do I want to save rules for IPv4? And it's going to offer to save my current rules. And, you know, I'm debating whether I should just say no to that. I am going to say no. I'm going to say don't save the current rules. I want to start up as it, well, I'll go ahead and save it. Why not? We'll save what we've got because we can always go in and edit it. And then it offers to do IPv6 rules as well, so I'll save those. And that's going to give us kind of our initial starting point of what's there. If I said no, I would just start with a blank file and I could write things out myself. But here it's going to go ahead and save over what I've got. And now I'm ready to start working with it.
So will that save our firewall rules or our routing configuration?
So it's actually saving both, sort of. So as far as the firewall rules, everything is part of that IP tables persistent package, right? So that is going to be saved. As far as routing, if we had routing rules in place, they'd be copied over. We really don't have any. But there is one other place where we have to look when it comes to routing, and that's what's called IP forwarding. So in the Linux kernel, there's actually a rule that they have that says packets are not allowed to jump from one network interface to another interface. That packets have to be destined for this computer or we throw them away, right? If we're going to be a router, we don't necessarily do that, right? Sometimes a packet comes to us that's destined for somebody else, so we need to forward it along. And that packet forwarding is turned off by default, and that's actually stored somewhere else. So there's two different sets of configuration we need to worry about. So let me show you where those are, and I'll start with the IP forwarding. So if I go into /etc and just kind of pull up a listing of all the stuff that's in there, there's one configuration file called sysctl.conf. All right. Now this file is not an IP tables configuration file. This is a Linux kernel configuration file. So it's configuring how the Linux kernel works. And if you dig around inside of it, I'll do a sudo edit /etc/sysctl.conf. If you dig around inside of it, you'll find a ton of settings, most of which have absolutely nothing to do with routing, and so it's all over the place. But there's a few options in here that specifically deal with routing. And the one I'm looking for is the IP forwarding option. So we can find it right here. You'll see a note. It says, uncomment the next line to enable packet forwarding for IPv4. And the line reads net.ipv4.ip_forward equals, and this is a value that we can change. Now, by default, it's set to 0. 0 says do not allow packets to jump from one interface to another. I want to change it to a 1. So all I have to do is uncomment that line. When I remove the pound symbol from the beginning of that line, now it's going to override that value and set it to 1. That's going to enable packets to jump from one interface to another. That setting was turned on by UFW and allowing, well, actually, no, it wasn't. UFW is in host mode by default. So yeah, well, it wasn't turned on there either. So this was off before. So I need to change it. And when I save that file, it takes effect when the system boots, or I can force it by saying sudo sysctl-p to make it parse that file again. And you'll see it output right there on the screen. It just set that IP forwarding to 1. And now when I reboot, that's going to stay, or right now it's turned on as well, and I'm allowing that to pass. So that one configuration setting is stored in a different file, right? But everything else is now being written to disk inside of /etc/IP tables. So if we go into that folder and take a look, you'll see two files. Well, depending on your choices a moment ago, you'll see potentially two files. rules.v4 and rules.v6. If I had told it not to save one or the other, then this folder might be empty. Now I'd have to go in and create it. But rules.v4, that's where our IPv4 firewall and routing rules are. And then v6, that's for IPv6. And if we edit one of those, so I'll just do a sudo edit rules.v4, I can open that up and I can see everything that's inside of it. Now, looking down the list, I see a lot of default rules here, which are kind of important. We need some of these in order to function. But I also see a lot of UFW stuff that got left behind, right? So all of this UFW, that's all from the uncomplicated firewall, and it's got its various settings for what it's doing. You'll notice that really just about every line in here has come from UFW in one form or another. And if I'm not using it anymore, well, I can just come through and delete these out. I don't need any of this UFW stuff. I'm going to be getting rid of that. And now I'm really left with just 3 lines. Okay. The lines are input, forward, and output. And so what we're seeing here is what are called the IP tables chains. These are the chains of communication that we have as data reaches our computer. Input is traffic coming into our computer. Output is traffic going out of our computer. So when I browse the web and I type in www.google.com, I'm hitting the output rule. I'm going out to Google. And when Google replies, their reply is coming on my input rule. It's coming back to me. And then if I'm a router, I might receive something as input, but then forward it along as output, and that's the forward rule. So I'm forwarding. Now, each of these are set to accept. I'm allowing all of this. I'm now a true router. I'm wide open. I'm allowing any traffic to come in, be forwarded, and go back out again, which is not a firewall, right? So even though it says star filter at the very top, I'm not really filtering anything just yet. And beside them, I see various counters that are showing that traffic has been flowing over them. Notice how my forward accept is set to 00. I just turned on forwarding. I haven't forwarded any traffic, so there's no traffic that's been flown through that particular chain just yet. But at this point, I've got my firewall configuration in place. It's right here. I can save this file now, so I'll go ahead and just save it. It's written to disk, and now I'm ready to get going with IP tables.
Now, what about more advanced features like NAT? Does IP tables do that automatically?
It doesn't. So I am really, right now, I am the true definition of a router. I don't modify any traffic. I take stuff in on one interface, and if it's destined for a different network, I look to see if I have a way to get there, if it's in my routing table, and then I'll forward off to that other destination without manipulating traffic at all. This type of router is not very common, right? Most people are doing things like NAT or manipulating the traffic. When you manipulate traffic, it hurts performance. This type, a true router, I usually only see these in like storage area networks where performance is the number one concern. You want to do as little manipulation as possible to move the data as quickly as possible. So like a core router or a SAN router, that's where you'd see something like this. Otherwise, you are going to be stacking things on like NAT rules. NAT rules let us hide complexity, right? We have private IPs on our internal network, and we want to all share a single public IP as we go out of our system. So in those scenarios, we'll need to get that up and configured. So let's say that I want to configure full NAT, like double NAT, where I NAT outside traffic coming in, I NAT inside traffic coming out, and I just want to get up with a quick and dirty configuration like that. Or if I want to do something specific, I'm NATing just my internal network to whatever my external IP is. Well, we can come in and punch in a few simple rules for that. When it comes to modifying IP tables configuration, you can do it by editing the text file, but you're usually better off using the command line because it'll help you spot errors. It'll give you better error feedback than editing the text file. So if I want to turn on double NAT, I would come in and just say sudo IP tables -t NAT. So I'm setting up a rule for the type NAT. And then I would say -a, which is going to tell it when to use this rule. So I'm adding a rule, and I want it to be added to post routing. I've already routed the traffic. Now I'm doing something to it before it leaves my system. And then I'll tell it what I'm going to do. J is jump. I'm going to jump to a particular action. And the action I'm going to take is masquerade, if I can spell it right. There. Masquerade. Masquerade is NAT. I want it to NAT and translate it to the IP of this router. So they're going to share the IP address of this router. Now that would NAT anybody. I would usually be a little bit more specific. So I'm going to do another add rule. And this time I'm going to add a little more to it. Before I do the A for add, I'll do a -s to specify a source. And I'm going to say that I'm just doing this for the 10.222.0.0/24 network. That's my internal network. I want to NAT for that network and nobody else, all right? And so when I run that, it's going to add that rule in place. And if I want to see the rules, I can just do sudo iptables-save. I know it sounds like that command's going to save the rules. It actually doesn't. It just outputs on the screen what my configuration looks like. And so when I run that and I look at my configuration, I can see some of those rules that I just typed in right up here at the top. So I've got -a post routing masquerade, -a post routing, and there's the source and masquerade. There's the two rules that I just made, and now I can save those into my configuration. My running config still has all the UFW stuff, so it's going to put those back. But once I save this, then it'll actually be in my main config. And so what I'm going to do is I'm going to rerun sudo iptables-save, and I'm going to pipe that into sudo t/etc/iptables/rules.v4. That's going to allow it to output to my screen, but it's also going to write it to the file and save that configuration to disk. And so now it's saved to disk. I can go and I can edit that file, which is rules.v4. And now I can see my entries right there at the top. I've got the junk UFW stuff at the bottom that I could remove later, but I've got my entries right here for pre-routing. It's created the NAT section. I'm now a NAT router.
So it looks like we're all set up, but are there any follow-up tasks that we need to do?
Oh, there's a lot more. You'll probably want to configure things like firewall rules. You might want to do port forwarding and so on. We're going to do some more episodes on those. But as far as getting a basic Linux router up and running, these are the steps.
And this episode was all about the functions of IP tables. We learned how to configure packet forwarding in Linux, and Don showed us how to configure NAT routing in IP tables as well. But don't go away because we've got more LPIC coming up in the next episode, so stick around.
Thank you for watching IT Pro TV.
Need to expose a public server, but it's behind an IP tables NAT router? Stay tuned, we'll show you how to configure port forwarding.
You're watching IT Pro TV.
Welcome back. We're here with more LPIC 2, and today Don's going to talk to us about configuring port forwarding. Can you give us an overview of what we'll talk about in this episode?
Sure. Anytime you've got a server that you want to be public, but it's on a private network, it's behind a NAT router, we've got to have some way to expose ports out there to the public world. And network address translation and port forwarding can do that. So in this episode, we're going to take a look at how we can configure IP tables to do proper NAT routing and session tracking. And we're going to do port forwarding, which means we're going to have to set up a little bit of source and destination NAT to be able to get that all working properly. And by the end of the episode, we will have set up the rules to expose a private server on a public network.
So just to sort of start from square one, what are the basic steps that we need to complete to enable port forwarding?
All right, well, the first thing we have to configure is connection tracking, right? When a IP packet comes through on a router and we modify it, we do network address translation, we change the addresses that are there, and we send it along, well, somebody's going to reply back, and we have to be able to match one and one together. How do we know that this modified packet matches the original source packet to get it to the right destination? So connection tracking is step one. We've got to get that in place. Then step two, we have to set up destination NAT. When we're sending traffic to a destination, well, the traffic coming from a public network is destined for our router. We have to modify it to make it destined for the internal server. So we're changing the destination. Now, the internal server is going to reply back, and when it replies back, we need it to come back to the router as well. So we're going to have to do a little source translation to make that happen. And also, as we send the packet all the way out to the original requester, the source needs to be the router, not the internal server. So we have to configure source NAT. So that's kind of our three steps: connection tracking, destination NAT, source NAT. Once we have all three of those things in place, we're now port forwarding, and we're done.
So step one is connection tracking, but doesn't IP tables do that already?
It does, sort of. So with the connection tracking we've got, and so when we talk about connection tracking, we have to remember how protocols like TCP work, right? Transmission Control Protocol does a handshake when somebody connects. So there's a SYN message that's sent. SYN is short for synchronize. And so it does a synchronization. The other side will respond with an acknowledgement. So it's acknowledging that it got that, and it sends a SYN as well. So there's a SYN ACK. And then the original requester acknowledges that, so there's a reply back again with another acknowledgement. So it's a two-way handshake that happens. Well, the router can see all of that. On a true router, it ignores it. What does it care about sessions? It just moves data from one network to another. But when we're doing NAT, we've got to keep track of that. We've got to track who talked to who, so we know that it's a session, and that follow-up packets don't have to do a handshake. They can get sent right to where they need to go, and we're in good shape. So a true router would ignore all of it. It would not track that by default. And in the last episode, we had set up our IP tables router as a true router initially, and so it wasn't tracking it. But the moment we turn on NAT, it does track it. But even NAT by default is really just doing this in bulk across the two interfaces. It's not handling it for individual ports. And so we need to go in and actually get that set up. We need to add a little bit more to get connection tracking in place. So let me show you what that looks like on my system. I'm going to do just a quick sudo iptables-save to show you guys where I'm at. So I've got a basic configuration that's in place. You can see where my input, forward, and output here are all set to accept. I'm just allowing traffic to flow through my system unfiltered. And then in the last episode, we had configured some basic NAT rules here. So for example, I'm allowing everything to be NATed right here with this rule, which I could probably remove that. I don't necessarily need it. But I also have another rule that is saying when my internal network travels through the router, it's going to get NATed, and it's going to masquerade the interface it leaves on, which would be my public interface. That's the normal rule we would have on a NAT router. And because it's covering this entire subnet, 10.222.0.0, it's covering all of those addresses, it has to do session tracking. So when traffic comes back, it knows which host to send it to. So there is some session tracking that is happening already. But if I'm doing port forwarding for a particular protocol, I'll want to configure session tracking specifically for that protocol. So let me give you an example. Let's say I've got a MySQL or a MariaDB server running on my network. Well, it uses TCP port 3306. So I want anybody connecting to my public interface on port 3306 to get sent to my internal MySQL server. All right. So I need to create a rule for that that allows that traffic to come through and tracks the session. So a rule that does that is going to look like this. Let me just get here into my command line. I'm going to say sudo IP tables dash A. So this is the chain that we're connecting to, or the action. I'm going to forward. So I'm forwarding traffic, and then I'll say the in interface. What interface is it coming in? And then the output interface. What interface is it going out? Well, my internal interface, or sorry, not my internal. I have to remember, it's easy to confuse this. This is the traffic, the interface the traffic is coming in. These are people from the internet. They're coming into my public interface, whatever interface is connected to the network. So for me, that's my ENP0S6 interface, right? And yours might be called Ethernet 1 or some other name, so you'll need to look at your interfaces to find out what their name is. Mine is ENP0S6. That traffic is coming from the internet, and then I need to send it to my internal network. And my internal adapter, that's going to be the output adapter, so I'll say -O, is going to be my ENP0S5. So that's my other adapter. So I'm going to forward over to it. Then I need to tell it the protocol, so I'll say -P, this is TCP. I'll follow that up with --SYN. I'm expecting a synchronization to happen over this, right? If this were UDP, we wouldn't have that. With TCP, we do. Then --D port, the destination port. So this is traffic that's coming in my ENP0S6 interface with a destination port of TCP 3306. Now it knows what traffic to look for and recognize. After that, I can say -M contract. I need to track the connection. This is coming in on 3306. There's going to be a reply from the internal server, and there's going to be follow-up packets that come later on. It's all a part of this connection. So I'm telling it to perform connection tracking. Then CT state. CT state is the connection tracking state. When a first packet comes in, this is a brand new communication. So I'm looking for new connection. So CT state, I'm setting to new. And then lastly, -J, I'm going to jump to what my final ruling is going to be, the action that I take. And in this case, I'm going to accept that traffic. So when I do that, it's going to watch, whoops, I've got a mistake in there. Let me find my typo, -A4, -I, -P. I just have a simple mistake in here. I just have to find it. -M contract, dash CT state. I'm missing an extra dash. There we go. Now it's happy. And so once we've got that in place, the hardest part is typing. Once we've got that in place, now it's looking for any new connection on port 3306. It's accepting it and allowing it to cross from my outside to my inside interface, and it's tracking the connection. So kind of an important phase there.
So that rule covers the first packet, but do we have to create another rule for follow-up packets?
We actually do, and that's because the connection state here is listed as new. The follow-up packets won't be a new connection, right? A new connection comes in, that's a SYN that comes through, reaches the internal server, and then there's an acknowledgement, right? And after that SYN ACK process is done, after the handshake is done, we now have what's called an established connection. So an established connection is where we're already talking to an internal host. So I need to create a second rule for that. And this one's a little bit different. I'm going to just use my up arrow here to bring that command back. So I've got sudo IP tables -A forward -I ENP0S6 and so on. So everything here is pretty much the same, except I can get rid of the port information. So I'm going to get rid of the -D port and -SYN, -P, TCP. So we're removing each of those pieces. I'm keeping the contract, and I'm saying CT state, and instead of new, I'm going to change that to established, related, like that. All right. I don't need to look at the ports and other things because this is a session that's already in place. The first command that I entered set up the connection tracking. The second command is now marrying that together with all of the follow-up packets. And so these are going to be allowed to come in as well. We're accepting those. And so now the initial packet and all follow-up packets are going to be allowed to pass through the router to be able to get to this internal host.
So now that we're letting the packets in, how do we redirect them to an internal host?
All right, and so that's kind of the tricky part. So technically it is working right now that traffic from the outside will hit my outside interface. It is accepted. It's allowed to pass to the internal interface and it's going to go to the inside, right? But where is it going to go on the inside? Well, it's actually not going to go anywhere because the outside traffic has a destination address of my router. I need to NAT that. I need to do network address translation and change the destination from the router to my internal MySQL server, right? So this is where we're actually going to jump in and do NAT. So I'm not actually doing NAT in my first two commands. I'm just doing session tracking. Now I'm going to come in and add the NAT piece to it. So I'll say sudo iptables -t NAT. So I'm adding a NAT rule. And then -a, this one is going to be pre-routing. So before I route from one interface to another, I need to change the destination so that it knows which interface to go to. Because right now, it's going to route it to my outside interface. The traffic's already on the outside interface. It's going to expect the SQL server to be right here on my router, which it isn't. So I've got to do this before I route. So pre-routing. Then my incoming interface. So this is coming in my public interface, which is ENP0S6. And I'll follow that up with -p TCP. So this is TCP for the protocol. --d port 3306. So this is a connection to my MySQL server. And for -j, normally this is where I would say I accept the traffic. But I don't want to just accept it. This time, I'm going to jump to a different action, which is DNAT. I'm going to perform destination network address translation. I'm going to change its destination. And I'll say --2 -destination. And now I can specify the new destination. And this would be whatever IP address my MySQL server had. So in my case, I'll say it's 10.222.0.100. That's my MySQL server. So whatever destination this packet had, I'm now going to change it and point it to this new destination. All right. When I run that, that's going to put that entry in. Now, traffic's going to come in my outside interface, get translated for its destination, then it goes to routing, and routing says go to the inside interface. It'll hit the inside interface and go to the MySQL router. Now, the MySQL router is, the MySQL database, there we go. The MySQL database is going to receive that packet, and it's going to do whatever MySQL chooses to do, and it's going to reply. When it replies, well, the source is the MySQL server, and the destination is this external host that contacted us. Well, that destination is okay. The external host is who we want to talk to. But the source is a bit of a problem because the source is an internal IP, 10.222. An outside person can't get to that. So when it replies, I need to do source NAT and change that source to the router's IP. And that way, whoever's on the outside will know to reply to the router, not reply to this internal IP. The command is similar. So I'm going to just kind of bring up my, my previous command, but it is a little bit different. This one is going to be post routing because the destination is an external host. The destination is right, so it'll know which interface to jump between. But then as it's leaving the router, that's where I'm going to change the source to match the router. All right. So post routing, we're going to change it. And then here's where it gets a little bit weird because now the input and output interfaces are flipped. Now this is traffic that's coming in the inside interface. So I need to modify this to be ENP0S5. So now we're doing -a post routing, -I ENP0S5. The protocol is still TCP. That hasn't changed. The destination port is still 3306. That hasn't changed. The destination is not any different. So we're kind of not messing with that. But we do need to change our source NAT. So here's where I'm going to say -j, and it's going to be SNAT this time instead because we're doing source network address translation. And we will change it. Instead of saying -destination, we'll say --2-source. And now we'll put in the IP of our router. You know, that's what we want it to be. Or we could say masquerade here if we just wanted to use the main public interface. Or if I had an actual public IP that I was assigning to this, I would put in whatever that was. You know, maybe like a 209.251.133.104, or, you know, whatever address it is that we're attaching on the outside. That's what we would put here, okay? And that way it knows to modify the source. And this will typically be, if you're just doing standard port forwarding, this will be whatever IP address is on your WAN or outside interface so that it knows to change the source to match that. And once we put that into the system, now it knows what to do. Whoops, and I'm missing something. Can't use -i with post routing. Oh, actually, I see what I did. So we were doing pre-routing originally, so I was working on the input interface. Now we're doing post-routing. So we've already routed. We've already moved from our input to our output. We're finding our output to go and move along. So I put the wrong interface in. So let me go and change that. And we will switch that from a -i to a -o. So we're going out of the router. And this one is going to be going out, ENP0S6. There we go. And so that's going to be the proper way. And we specify the IPs that we're going to change to. So we run that. There we go. Now the rule is happy, and we've got that one in place. So now that that's corrected, we've got these different rules in. I'm going to do a sudo iptables-save so we can see what this whole setup looks like. We've configured port forwarding now, but there's 4 rules that all went into that port forwarding, so it gets a little bit confusing. And so if we look down here under my filter section, right, here's where we're doing the connection tracking. So we've got the first line that's going to be forwarding that traffic, that's allowing it through and setting up tracking new connections. Then we've got the second rule that's allowing the established connections, the follow-up connections to pass through. So that's what's actually allowing the traffic through my system. And then up at the top, under my NAT section, that's where I've got the rules that's doing the source NAT and destination NAT. So right here, I can see my destination NAT rule, and then down a few lines, I see the source NAT rule, and those are both in place. Getting the first one of these created is kind of a bit of a headache, but then when you want to create a second or third or fourth or whatever, you're just kind of copying and pasting these rules, changing the port numbers, changing the IPs, and you're in business. So it's a little bit of a headache. But now, any traffic that comes in on my outside interface destined for port 3306, we're going to perform source and destination NAT on. We're going to allow it. We're going to transfer it to that internal IP, and the replies and follow-up communications will work as well. So there's a lot that goes into it, but once it's in place, it's rock solid. I just need to save this to disk. So I'll just pipe that into sudo t/etc/iptables/rules.v4. That's going to save it, and now I'm good to go.
And just like that, now we know the basic configuration steps for port forwarding. And just as a reminder, those steps are connection trafficking and configuring DNAT and configuring SNAT as well. But that's not all that we have for configuring port forwarding with IP tables. We got more IP tables coming up, so stick around for the next episode.
Thank you for watching IT Pro TV.
Most Linux firewalls are just using IP tables in the background. So let's cut out the middleman and learn how to configure IP tables directly.
You're watching IT Pro TV.
Welcome back. We've got more LPIC 2, more on IP tables, and this episode is all about using IP tables as a firewall. So what are we going to learn today?
Well, we are going to dive into IP tables itself. There's a lot of front ends that are available for IP tables that are out there, but if you know how to configure the IP table system itself, you'll be much more ready when you jump onto systems you've never used before. So a really cool thing to do. That's what we're going to look at here. We're going to learn how to write firewall rules to allow traffic, to block traffic. We'll talk a little bit about the organization of those rules and how they're stored in the IP tables configuration.
So let's start with chains and actions. How do they work within IP tables?
All right, so if you've worked with IP tables at all, if you've looked at the configuration, then you have, at a minimum, seen what are called chains. Chains dictate the order that traffic flows through your system. And you can take various actions at any spot as you move from one chain to another in the system. So let me show you what that looks like in just a basic IP tables configuration. So I've cleaned up my configuration a good bit. I'm going to do sudo iptables-save just to take a look. I've removed all the extra rules we put in other episodes. So this is really, really simple. Basically, we're operating as a true router. We've got 3 chains defined: input, forward, and output. And I'm looking under the filter section. You'll also have a NAT section if you're doing network address translation. The firewall doesn't really get involved with network address translation. The rules are all maintained down here in the filter section. And yours will probably look just like mine by default. Input, that's traffic coming into the firewall. And right now I'm accepting everything. Forward. Forward is traffic that I move from one interface to another that I'm routing, and I'm accepting everything there as well. And then output, that's traffic that I'm allowing to leave my system, and that one's set to accept everything. What I'm actually seeing here is a chain followed by an action. All right. The chains are input, forward, and output. Pretty self-explanatory. But the actions are a little bit different. And some people will call these jump actions because we use the -J command when we set them. But the jump action is normally going to be one of a few different things. It could be accept. I think all of mine are accept right now. It could be drop. Drop says, throw that traffic away. Don't let that pass through. There's also reject. Reject says, we're going to throw it away, but we're also going to tell the person, the sender, we're going to tell them that we rejected it. So we give them a notice. Notifying somebody that traffic is rejected is nice because it closes their session, and so it lets them move on. But if we're worried about denial of service attacks or things of that nature, it can actually slow our system down because we're wasting a lot of time sending these rejection notices. So drop is more common than reject, but you can do either one. And then there's also log. We can log the traffic if we want to keep a record of what passed through our firewall at any given time. So those are all jump actions that we can take attached to a chain. So looking at our config, those are the things that are going to make up the configuration, and we use those to build our rules.
So now that we kind of have a grasp of the chains and actions, how do we connect them to create firewall rules?
All right, well, that's where our command line comes in handy, right? So let me give you a few examples so we can see how this works. For example, let's say that I want to allow people to get to a server using SSH, right? So SSH uses TCP port 22. I want to allow that through the firewall. Well, in my default configuration, they can already do that. I'm accepting everything. Everything is allowed to be passed through. So what I need to do first, I need to block everybody's access to SSH, and then I can add other access in. I could choose to just block everything, and then just allow little windows that I want to have open. We can certainly do that, but I'll block just SSH to start. I'm going to say sudo IP tables, and then -A. This is where we specify the chain, and this is going to be our input chain. So this is traffic coming into my firewall. Then the protocol, -P, TCP. So this is the layer 4 protocol. So this will usually be either TCP or UDP. SSH uses TCP. I'll follow that up with the destination port. The destination port with SSH is 22. I can type 22 in here, or there's actually an alias for SSH. Sometimes we don't know which aliases are there, so I usually just type the number to be on the safe side, but I do know there is an SSH alias, so I'll type that in. And then -J, here's where we jump to take an action. Well, the action I'm going to take, drop. I'm going to throw away any traffic that comes into my firewall with a destination port set to SSH. That's going to throw it away. Now, when I run that, people are not going to be able to SSH into my system anymore, right? They're going to get blocked out. So I need to allow other traffic first before I get too far.
So now that we have a grasp of the chains and actions, how do we connect them to create firewall rules?
All right, well, that's where we dive into our command line and we start stringing this all together. So let's go ahead and jump to mine and we'll kind of look at that process. So let's say, for example, I want to restrict who's allowed to come into my system using SSH. So I want to block SSH traffic and just allow certain people. Well, the default configuration is accepting everything. So everybody can already get to SSH, so I don't really have to do much. But I need to block some people. So I'm going to create a block rule. Now, before I create a block rule, I need to create an allow rule to allow myself in. I don't want to lock myself out of the router. If you're on the console, it doesn't matter. You can do it. But if you're remoted in, I'm SSH'd into this server, so I need to make sure I allow my own traffic so I don't lock myself out. So the first thing I'm going to do is create a rule that allows me to connect to this server using SSH. So to start with that, I will say sudo IP tables -A. So here's the chain that I'm working with, and it's going to be my input chain, traffic coming into my server. The protocol is going to be TCP. SSH uses TCP, so this is my layer 4 protocol, my transmission protocol. So I'll put that in there. And then, my transport protocol, use the right term. Then I need to specify the source. So -S, who is it that I'm allowing? I'm going to allow my laptop, which is 10.222.0.50. I want to allow that IP to come in. I also need to specify that it is going to use a session. So I'll do -M state so that I can allow the connection to come in. And for the state, I need to specify -- state that I'm allowing new and established. So I'll put new, comma, established. So this will allow me to initially connect and then all of my follow-up packets to be able to connect as well. And then lastly, I'm going to say -J, and this is the jump action. I'm going to jump to accept. I'm going to accept that traffic to pass through. And actually, I left one thing out. I said the protocol is TCP. I kind of need to tell it that I'm dealing with SSH. That's the destination port. So I'm going to go way back to that -P TCP, and I'm going to add in a --D port, and I'll set that to SSH. I could just type 22. That's the port number, but there's an alias in it for SSH. Sometimes I don't know if there's an alias or not, so I just default to putting in the port number, but in this case, I do know there's an alias. So I'll put that one in, and I'm going to run that. All right, that's going to put that rule in, and you'll see the beginning of the command has the chain for input, and the end of the command has the action accept. So I'm allowing some type of traffic to come in, and then everything in between is what's defining that traffic. Now I can follow that up with a rule that blocks all other DHCP traffic, or not DHCP, SSH. I want to allow this SSH and block everything else. So to block everything else, it's a shorter command. I can say sudo iptables -A input, right? So grabbing traffic as it comes into my system, -P TCP, and then --D port SSH. So everything's kind of the same so far, but then I can just go straight to -J drop. I'm going to drop anything else that comes in using SSH. So now we've allowed one particular IP to come in, and I could have done a whole network range. I could have said 10.222.0.0/24, got that whole class C or whatever. So it's up to you how you want to specify that. But once that's in place, now I'm filtering who has access and blocking unauthorized IPs. I just need to save my configuration. So I'll do a sudo iptables-save, and I'll pipe that into sudo t/etc/iptables/rules.v4. And that's going to save that. And now I can see that configuration down here under filter. I've got my input rule that's allowing my computer to connect, and then my input rule that's dropping everybody else right there in the config.
Now, if we want to add or change rules at all later on, do we follow the same process?
You can. So when you use the command line like I just did, it does a pretty good job of trying to put stuff in the right order. But the order does matter. The rules are applied from top down. So they're applied in the order they're listed in the configuration. So order is kind of important. And you might want to manipulate something or add in some rules. Like if I had put my rules in backwards, if I had done the block first, it would have locked me out of the firewall, right? I would have been blocked out of the system. My SSH traffic would have been blocked when I put the first line in because I hadn't done the allow yet. So instead of using the command line, I could have just directly edited this text file. So if I edit that, I can put in more than one rule at a time. I can put in 10 rules, and they won't take effect until I restart the IP tables service. So that allows me to go in and start to kind of manipulate things in a different manner. So for example, let's say I want to edit that. I'll do sudo edit /etc/iptables/rules.v4. And when I go in there, I can insert lines, I can do whatever, I can move things around, cut and paste, and so on. And once I get it all set the way I want, then I can save it. So maybe I want to do exactly what I just did, but maybe not for SSH this time. Maybe I want it for Telnet or some other protocol, SNMP, or I don't know, something. Well, I could just copy and paste these lines, and by doing that, it just saves me a little bit of effort. I'll copy that, come down to a blank line, paste it in, and now I can just come through and change the protocol. I also want to use Telnet, so I'll change that port number to 23, and we'll need to modify that on the drop rules as well. And so now I've got that set. Coming in here and making changes like this is faster, but it's easier for you to make a mistake. And if you make a mistake in here, when you restart the IP tables service, it could cause the service not to start. Now IP tables isn't running, and you've effectively broken your networking on your system. So that's bad. We don't want that to happen. So they encourage you to use the command line whenever possible, because if you have an error in your command, it'll tell you right there on the screen, and you can fix it and go. If you're doing text editing like this, you just want to make sure you test out this config on like a non-production system before trying to roll it out in production. But once you do this, you can just exit out, and that doesn't take effect right away. If I do a sudo iptables-save and I look, those TCP lines aren't there. But if I restart it, if I do sudo systemctl restart IP tables, and when I run that, it's going to restart the service. It's going to read the configuration from disk. And now if I do a sudo IP tables -save, I should be able to see, there we go. I've got my SSH rule and my telnet rule are both in there, and I did it by editing the text file. So a little bit dicey there, because if I make a mistake in the text configuration, it will stop the firewall from starting, but it's a lot easier to make bulk changes. And if you're copying and pasting, it's typically pretty safe, but that's what it's going to take to get in and start to modify those rules manually.
Now, are these rules bidirectional, or do we need to allow return traffic as well?
The rules are not bidirectional. So when we create rules like this, I'm allowing traffic to come in and not necessarily allowing traffic to come out. Now, the way my firewall is configured right now, that's not a problem, because if I look at my output, my default output up here is set to accept. So I'm allowing everything out anyway. So if I'm allowing traffic to come in, then the traffic going out is already allowed. I don't have to worry about outbound rules, right? But if I tighten that up, if I start really getting strict, in a high security environment, we might configure our server's firewall to say, don't allow any traffic to go out unless we specifically authorize it. And in that scenario, you would have to create the flip side of this rule to allow the return traffic. And it doesn't look much different. Let me add in, let's say that, well, we can use SSH as our example still, right? So I'm allowing SSH traffic coming in. Now I need to allow the responses to go back out. We just kind of flip around some of our values. I'll say sudo IP tables -a, and instead of input, this time I'm going to say output. I'm allowing traffic to go out of the system. The protocol is still TCP, but now I need to either specify a destination of where I'm going to, or a destination port, or something to be able to match this traffic on. Well, in this case, if it's SSH and I'm allowing this traffic to go out, well, I don't know the destination port. I don't even know the destination IP. It's whoever's connecting. Well, I guess in this case, I only authorize my laptop. So I do know the destination IP. So I could say -d 10.222.0.50, right? Traffic going back to my laptop. That's what I want to allow. If I didn't know the destination IP, I could leave that off. And then I could specify the port. Now, the port, I don't know the destination port, because TCP generates a pseudo-random port from anywhere between, I think it's 1024 all the way to 65,534. I'm not going to be able to guess what it is, but I do know the source port. This is traffic going out. So I could say --s port for the source port of 22. On the server, that would be the source port. On the client, that would be the destination port, right? Destination of 22. So I'm just kind of flipping that around. And I can still track state and what that state is going to be. Now, I'll put new and established on this one. You won't normally have new traffic that quite matches this. This would be more of if I had a firewall and I was allowing traffic from inside of my network passing through, versus this is the host that I'm filtering. If it was traffic passing through, then it would be a little bit different. But when I run that, it's going to add that into my system, and now I've allowed that other pathway going through. So the way my firewall is configured right now, I didn't actually need it, but if I was really locking things down, that's the way that I would enable the return path of that traffic.
Now, how do we make sure that it all works? Can we monitor what IP tables is doing?
Yeah, there's several different ways to monitor it. You've kind of seen one already. When I do a sudo IP tables -save, and I look at the various rules, the rules have counters on them. See these in brackets and the numbers that follow it? So those are rules that are letting me know if traffic is matching those. So I can see some of that. There's actually a different way we can look at it that I like to do, which is sudo IP tables -vn and a capital L --line. So what this is going to do is give me some verbose output to let me see the activity on the various lines. And by line, it's each of our rules that are in place. And so when I run that, it's going to give me some output, and I can see the rules and the sessions. See, here's the SSH rule and the telnet rule, and I can see if there's traffic flowing over them. The cool part here is I can turn this on, and then I can go generate traffic. And do I see the numbers go up? If I do, then I know it's working. If I don't, then things aren't matching that, and I know I've got a problem I need to go and figure out. What I'll normally do is I'll take this command, but I'll add a little more to it. I'll do a watch -n 0.5, and then the IP tables command. And by doing that, it's going to refresh every half second. And so now it's like a live view, and I can start generating traffic and see these numbers tick up to know what's matching. You can actually see some of my stuff up here is already increasing. Ubuntu must be doing something in the background, maybe updates or something. But I can see that activity is occurring, and nothing's matching my rules because I'm not flowing SSH traffic over this link right now to be able to match it. But it's a great way to see if your rules are actually functioning. There is another thing you can do if you want to monitor something maybe a little more long term. I don't want to sit here and watch this screen all day. Is that we could create additional rules that log the traffic. So for example, I could say sudo IP tables -a input -p TCP -d port SSH. So I'm looking for SSH traffic, and I'll do a -j log. I want to log that traffic. Now, if I do a sudo IP tables -save, IP tables, I have to spell it right, save, there. I can see where it creates that log entry right here. And it's kind of like a duplicate rule, but they'll all take effect. So it is going to log, and now I can use my journal CTL or my syslog to see that traffic. It'll all be logged right in there, and so I've got a record that I can monitor with. So all different ways that we can kind of monitor IP tables and see if the firewall is working.
And in this episode, we got to look at the chains and actions used in IP tables. We talked a bit about creating and modifying firewall rules. We looked at managing bidirectional communication. And Don showed us how to test IP tables to make sure that everything is working the way that it should. And that's all we have for this episode, but thanks so much for joining us, and we'll see you next time.
Thank you for watching IT Pro TV.
Building an FTP server? Stay tuned to learn about VSFTPD and how to set it up.
You're watching IT Pro TV.
Welcome back. I'm your host, Sophie, and I'm here with Dawn for more LPIC 2. Today's episode, we're going to be diving a little bit into something I'm definitely going to struggle to say, VSFTPD. So can you give us an overview of what we're talking about?
It just rolls right off the tongue, doesn't
it?
Well, we're going to start off with a little overview of VSFTPD and what it is, what it does. We'll get a chance to see how to get it installed. And then more importantly, our real focus today is how we can improve the security of what is an otherwise unsecure protocol. So that's what we've got lined up here in this episode.
So what can you tell us about VSFTP and why we would use that as opposed to another FTP server?
All right, well, there certainly are a lot of FTP servers. And in fact, if you're running an older Linux distribution, it may have an FTP server built into it. But when I say older, I really mean like 10 years or older, something you shouldn't be running, right? If you're running a modern Linux distribution, the odds are it does not have FTP installed by default. And that's because the file transfer protocol, or FTP, does not really include any true security. It transmits everything in plain text across the network. Anybody can intercept that, see what your password is. They can manipulate files in transit. It's got a whole laundry list of problems and reasons why you wouldn't want to run it. However, FTP has one big advantage over other protocols, and that's compatibility. Everything supports FTP. Mac OS, Windows, Linux, Unix, whatever it is, FreeBSD, you name it, they all support FTP. So it makes it easy to get files between systems. So if you're in a situation where you need FTP, you've got to pick an FTP server, and you want to pick one that at least gives you some kind of security. And one of those is VSFTPD. So I've got their webpage pulled up right here. VSFTPD, it stands for the Very Secure File Transfer Protocol Daemon. And when you look at their homepage, it says, probably the most secure and fastest FTP server for Unix-like systems. That may or may not be true, but the reality is if you need secure file transfer, you're probably going to use SFTP, a completely different thing, which relies on SSH and not FTP at all. But if you have to pick one, you might as well pick VSFTPD. It's kind of a neat FTP server because the person who wrote it is actually a vulnerability tester, a pen tester. It's a security professional named Chris Evans. And wait, Chris Evans? That's Captain America, isn't it? Hang on, let me check to make sure. His name is actually Chris Evans. So I thought I had it wrong for a second there. So Captain America himself wrote this FTP server. And if you can't trust Captain America, who can you trust? But basically, he built it to be as secure as he could without breaking the FTP standard. And he's actually done a really good job. If you ever have a chance to kind of read through the homepage, it's got some interesting things on there where he highlights like some of the other FTP servers that are out there that have had major security exploits in them. But that his server, his software, VSFTPD, has been so stable and secure that a lot of organizations trust it. And you'll see his big list: Red Hat, SUSE, Debian, FreeBSD, GNU, GNOME, KDE, kernel.org. Like these are just a laundry list of the biggest names in Linux, all rely on VSFTPD. And I always thought it was funny, ISC is on the list because ISC has their own FTP server, but they use VSFTPD because that's really a step up from your standard basic FTP server. So this server has kind of become ubiquitous across the internet. Just about every site that's out there that you hit that's running a public FTP server is using VSFTPD. So that's what we're going to be looking at here in this episode, and that's why we've kind of picked this one, but also because it's in the exam objectives, so that makes it a little important as well.
So since it is important that we know kind of what this is and how it works, how do we get VSFTP up and running?
Well, it's really easy. I think that really every Linux distro has VSFTPD in their repositories, so you usually don't have to go and download it. I mean, you can download the source code and compile it and so on, but there's almost always a package available for it. And on some distros, it's their default, so they just call it FTPD instead of VSFTPD because it's their standard FTP daemon. But I'm on an Ubuntu 20.04 box, and on this one, it is actually called VSFTPD. So if I want to get it installed, I just need to do a sudo apt install VSFTPD like that. It'll pull it up. It's a very simple application, so it just depends on one thing, SSL-cert, and that's for some of the security features we'll see at the end of the episode. I can just say yes to that, and it's going to go ahead, get it installed, and now I've got a VSFTPD server. I do need to start it up, so I'll do a sudo systemctl. I'll say enable, so it starts at boot time, and -- now, so it starts, well, right now. And we'll throw in VSFTPD. That's going to start that one up. And then one other thing I need to do, FTP is a little bit of a pain to get through firewalls. So I need to open up some firewall ports. Most protocols use one port. FTP can actually use many different ports. At a minimum, it's going to use two ports, TCP port 20 and TCP port 21. All right. However, most modern FTP clients will also use what's called a passive mode transfer, which can use any number above 1025. So that means like, I don't know, 50,000 possible other port numbers that are out there. So when we configure this, one thing we want to do is constrain that number of ports to limit it and allow that through the firewall also. So I'm going to start with sudo ufw allow FTP, and that's going to add the standard ports. If I do sudo ufw status, you can see where it's added. Oh, you know, I said 20 and 21. It did 21 and 22. 22 I already had in place. Never mind. 22 is SSH. I got to keep this straight. So it's adding 21. It didn't add 20. And that's okay because I know my passive mode transfer is going to take the place of 20. It used to be that commands were sent over 21, and then the data transfer happened over 20. Now commands are sent over 21, and then every data transfer is sent over the passive ports that are 1025 or higher. Well, if I need to disable passive mode, then I'll need to allow port 20 as well. And my little alias didn't do it. So I could come through and say sudo ufw allow 20/TCP, and that will be added to the list. The passive side is a little more difficult though. I usually restrict it to about 10,000 ports, and I pick a range that's easy for me to remember, which is typically 10,000 to 20,000. So if I want to allow that, I can type sudo ufw allow 10,000 : 20,000/TCP. So that's going to allow this huge range of ports, which we're going to be attaching to VSFTPD. And just so I don't forget, I'm going to add a little comment to that so I can just remember that that's for VSFTPD, passive mode, and I use spaces, so I need to put that in quotes. And just so I can remember why I made that. So when I do a sudo ufw status and take a look, now I know exactly why I've got those entered in there. But at this point, my server is up and running. I've got TCP 20, 21 open. I've got a range for my passive ports. I've now got an up and running FTP server.
So is that default configuration suitable? Like, can we just stick with that, or do we need to kind of configure it first?
Well, it's up to you. So the default configuration does actually work, but it probably doesn't achieve your security goals, right? So it's pretty insecure by default. And there's actually one problem right now is I've created this range of ports to use for passive connections. VSFTPD doesn't know that yet. I need to tell it that range. So at a minimum, I want to configure the passive port range. But there's a few other things I want to modify. Fortunately, VSFTPD's configuration is pretty easy to work with. I'm going to do a sudo edit /etc/vsftpd.conf. Notice it doesn't have a subfolder of its own. It's just right inside of /etc. That's kind of a little bit different than most of the software we've seen. And when we go in there, it's a well-documented file. It's got a lot of information in here on how we want it configured. And this is where we make decisions. Do I want it to run on IPv4 or IPv4 and IPv6? You'll notice mine says listen equals no. That might make you think, hey, it's not listening on any port. But there's an entry down here that says listen IPv6 equals yes. Well, that one implies that we're listening on IPv4 as well. So this is going to make sure that I am listening, even though that first line says listen equals no. That's why it's important to read the documentation sometimes. It doesn't behave the way we expect it to. Few other things we might want to change in here. I might want to restrict the IP addresses that I listen on. So if I have more than one network adapter, I could come in and I could say listen _address equals, and then specify the address that I want to listen on. So that's going to kind of tie it down to a single adapter. That'll help with firewall rules as well. In my case, I've only got one adapter, so I actually don't need that. So I can just leave it off. Let's see, what else do we want to do? Anonymous _enable equals no. Anonymous users are turned off by default. That may be what I want. With the default configuration, regular users can connect in and get to the system. Anonymous users cannot. But if I'm trying to set up a public FTP server, I need anonymous users to be able to get in there. So I'll need to change that to yes. Now anonymous people will gain access. Regular users can still log in as themselves, but anonymous users can connect as well. A few other things, we'll see local enable equals yes. That is, do I want local users to be able to connect? Maybe I don't. Maybe I only want anonymous. And so I could set local enable to no, and now it would just be anonymous users that get access to the system. The next line here is probably one of the more important ones. Write _enable equals yes. By default, VSFTPD is read only. When people connect, they can download files, but they can't upload. If you want to maintain a secure FTP server, that's one way to do it. Just don't allow people to upload stuff, and that saves a lot of pain. But if we want people to upload, we'll need to enable this, and we can do that by just uncommenting that line, and now write enable is set to yes. It does not grant write permission to anonymous users. So anonymous users, the file system has permissions too that still apply. The anonymous user will not be allowed to write no matter what, unless you really blow your security stack out the window. Let's see, what else? Oh, the only other thing I need to worry about are my passive ports. And if I remember right, that's actually not in the configuration. I'm going to have to add that in. I'm just kind of scanning across the configuration here to see if passive jumps out at me, and it doesn't. So I'm just going to go to the very bottom of the file, and I'm going to add 3 lines. First off, passv _enable equals yes. I want to make sure that passive mode is enabled. Most modern FTP clients expect that to work. Then I'm going to say passv _min _ports equals 10,000. And then passv _max _port equals 20,000. So now it knows the range of ports that I want it to use. So I'll put that in place. I'm going to go ahead and save that file. And then I'll do a systemctl restart vsftpd. That's going to restart it. And now I've got a pretty decent configuration. Anonymous users can get in, regular users can get in. The system is up and running.
And when those users do connect, what data are they able to see?
It depends on who they are. So if they're a regular user, when they log in, they'll see their home directory. So I've got a user account on here. I've got a home directory. So when I log in, I should see /home/dpossett. I'm a user. But if I'm an anonymous user, what I'll see is the contents of /srv/ftp. So /srv/ftp is an empty folder by default, and it's designed to hold stuff for anonymous users. So I'm going to create a file in here. I'll just call it anonymous content.txt. So there we go. Oh, I need to be an administrator for that. So I'll just drop it in there. So now I've got a file in there, and that's for anonymous users. And then I'm going to go into my home folder, And I'll create a file here, which I'll just call donpazette-content. And so now I've got that one as well. So now I can kind of see where I've got some files. So when I remote in and connect, I can tell where I'm connected to. If I fire up a client, like here, I'll fire up old FileZilla, and I'll connect to that server. So 10.222.0.51. I'm going to log in as dpazette. I'll punch in my password, which is password123, and then I want to tell it, that I'm using port 21, and we'll connect. We don't need to save passwords today. And it's warning me that this is a plain text connection. FTP is not secure, but that's fine. So I connect, and sure enough, I see home dpazette, and there's that dpazette content right there. I'm seeing my home folder. But if I reconnect, and if I leave the username and password blank, when I do that, let me disconnect. Now I'm going to connect anonymously, and what I see is something different. Now I see that anonymous content file right there. I'm in that other folder. So it just depends on the user context, what I'm going to see when I log in.
So once people are in the system, is there a way that you're able to monitor what files they access?
You can, yeah. So it logs a lot of this. It should be logging by default. I haven't actually transferred anything, so maybe I should, I don't know, download something. Maybe I'll download this anonymous file, so I'll just double click on that. Let me reconnect as my actual user account, and I'll download that file. So when we start going through and doing all of this, you're transferring files, you're grabbing things, it should be logging that. We can check. I guess I should have checked that before I started downloading the files. Let me go back into editing my configuration. So I'll do a sudo edit of /etc/vsftpd.conf. And in here, there's an entry for a transfer log. And that log, it's just called xfer. So let me search for that and see if we can find it. Right here, xfer log enable. Sounds southern, right? The xfer. So the xfer log or transfer log equals yes. So it is logging by default. So it should have logged the access that I just gave. If I go into /var/log and take a look, I can see vsftpd.log right there. And I'm going to tail that file. And I need to be an administrator, so let me sudo that. So I'm doing sudo tail vsftpd.log. And right here at the end, I can see the access coming in. I came in from 10.222.0.50. That's my laptop's address. And I connect. It shows my anonymous one. And I can see where I've downloaded that text file. Let's see. We've got right here is the anonymous content.txt file that I downloaded. And here's the donpazette content.txt file. So I can see exactly what has been kind of done on my server.
Now, FTP transfers data in the clear, so can we make VSFTP use encryption?
You can, yeah. You generally don't want to, and let me explain what I'm saying there. It's not that we don't want encryption, it's just that FTP sucks at it. So we want to use something that's a little bit better. Almost every Linux server runs SSH, and so that means you can use SFTP, which is Secure File Transfer Protocol. It's FTP run on top of SSH. That is very secure. Nobody can intercept or modify your traffic in transit, and it's built into every Linux system. You don't need an FTP server for that. I don't have to install VSFTPD. I just need SSH running, and I can use SFTP, right? So that's what most people will use if they want encrypted data. But if you have to use FTP, if you got some compatibility reason where you've got to use FTP, you can tell it to use what's called FTPS, and that is FTP over SSL. Very confusing, right? SFTP is on top of SSH. FTPS is on top of SSL. So we're basically relying on transport layer security, or TLS, to give us SSL security on or underneath FTP for our transfer. It's not very common. Not many people use it, but the functionality is there, and it's pretty easy to turn on. Let me go back into my config file. So I'll sudo edit /etc/vsftpd.conf. And I'm going to look for a setting which is called SSL. And we'll see if it's in here. It is. So right here, you'll see the settings for SSL. And there's three settings that really matter to us here. So one setting is SSL_enable. And right now mine says equals no. So it's not turned on. I'm not doing encryption, right? So if I want to, the easiest thing for me here is to just type yes, right? So now we will. But the two lines before it are kind of important. We need to provide a certificate and a private key to be able to do proper encryption. Now, it's going to default to Ubuntu's snake oil certs, which are, just temporary certs you shouldn't count on. I need to go and get real certificates, get them generated to either use Let's Encrypt or any of the number of other services we've seen, and get those certificates put in place, and then I can configure VSFTP to use them. But for right now, I'm just going to go ahead and use the snake oil ones. I will get out of my config. I'm going to restart VSFTPD, so I'll do sudo systemctl restart VSFTPD. So we'll let that restart. Then I can go back over to FileZilla. And in FileZilla, I've been doing a quick connect. So let me do a real connection this time. So when I define a site in FileZilla, I give it a site name. So I'll call this my Ubuntu server. And then over here, I pick the protocol. Now, if I drop that down, there's two protocols, FTP and SFTP. SFTP is the one that uses SSH. I'm going to choose regular old FTP. And then right beneath that, I've got the encryption option. And there's 4 options here. Use explicit FTP over TLS if available. So if it's available, use TLS. If not, go plain text. Then we've got require explicit or implicit. Explicit means I either have to use it or I get disconnected. Implicit means when I get connected, the server already assumes that I've got it turned on. It's kind of just 2 different modes for getting it enabled. Usually, it'll automatically negotiate, so we don't have to worry about it too much. And then the last one is, hey, just go plain text. Just go ahead and do plain insecure, and I get a little yellow triangle telling me that's the wrong choice. So I'm going to stick with use explicit FTP if it's available, and then I can specify my host, which is 10.222.0.51. I'll leave the port blank on this one. It'll go with the defaults, and I can choose to be anonymous, or I can actually log in. I'll choose normal. I'm going to log in with my user account, and I'll go ahead and hit connect on that. So it's telling me I haven't saved a password, so it's going to prompt me anyway. So we'll go ahead and get connected. When I connect the first time, it sees the certificate, and it says, hey, I don't trust this certificate by default. Do you trust it? And this is one of the snake oil certs. That's why it's not trusted. But I'll say, yeah, hey, I always trust that one. I love it. And then we'll just hit OK on that. And now I connect up. And I can see right here in my connection log, TLS connection established. I now have an encrypted connection to that server. So when I transfer files over the network, they're just as secure as when I go to web pages and use HTTPS. It's the same technology.
Well, this was a great introduction to VSFTPD. See if I can say that 5 times fast.
No, it's hard.
And some of its features, we got to look at the installation process and configuring some of those security options as well. And we're not quite done with this, so don't go away. We've got another episode coming up that's kind of related to this topic, right? We've got more of this coming up.
Yeah, we're going to tackle one more FTP server so we can see some different examples. Stay tuned for it.
All right, awesome. Well, then thanks so much for watching this episode. We'll see you next time.
Thank you for watching IT Pro TV.
One option for building an FTP server is to use pure FTPD. In this episode, we'll take a closer look.
You're watching IT Pro TV.
Welcome back. I'm here with Dawn for more LPIC, and if you've been following along in our episodes, then you know that we kind of started diving into FTP in the last episode, and in this episode we're going to continue that. So what exactly are we going to be talking about?
Well, this time we're going to learn about pure FTPD, which is another FTP daemon available inside of Linux. We'll learn some of its advantages over other products. We'll get a chance to see how to get it installed, and then how to configure it to be as secure, well, as secure as we can make FTP.
So what can you tell us about pure FTPD, and why would we use it as opposed to VSFTPD?
All right, well, VSFTPD is far more common and honestly is usually the go-to FTP server. But where pure FTPD kind of excels is it still has a focus on security like VSFTPD does, except it's very feature rich. It has a lot of really advanced features that are inside of it. If you take a look at their homepage, you can actually see a lot of that. So I'm on the pure FTPD, secure FTP daemon. This is a lot of acronyms today. And basically they highlight some of the features they have and so on. It's a great product. I will say I do normally go to the VSFTPD side because a lot of the features they have are ones that I don't necessarily need. But if you were running a large-scale FTP server, then you will find that you benefit from a lot of what they have. For example, maybe you want to do ratioed downloads for every 5 gigs of data you want to download, you have to upload at least 1 gig. Or you want to do moderated uploads, so you can upload into a temporary folder and an admin has to approve them. If you want advanced features like that to actually run a FTP site in a commercial environment, Pure FTPD has a lot of the features that will let you do that. So that's usually what drives people to using this one. So if you need advanced functionality, this one's your choice. If you don't, if you just need basic FTP services and you want it to be secure, VSFTPD in a lot of cases is a better choice.
So what does it take to get Pure FTPD up and running?
It's a little bit different than what we saw with VSFTPD. One of the big differences with it is that Pure FTPD, it can run as a service, as a daemon, running as the root account or system credentials, or it can run entirely in user space. So it's a very safe application because if it's running in user space, if it runs as my user account, for example, it won't have access to anything that my user account doesn't have access to. That's what helps it be secure, but it does make the configuration a little bit different. And let me show you what I mean. I'm going to go to my command prompt here and we'll get it installed. It is a part of Ubuntu standard repository, so I don't have to download it. I can just say sudo apt install pure-ftpd like that. So it's going to go and download it. Very streamlined, not a whole lot of package dependencies coming along with it. I'll say yes to get that installed. And there it goes. And once it's installed, we've got it. I can turn it on by doing sudo systemctl enable -- now pure-ftpd. And the first time you start it, this is where things get a little bit weird. We're going to get some authentication prompts that you might not be used to. Actually, mine just did it automatically for me. Perfect. If you get an authentication prompt here, you might actually have to provide your user account's credentials up to 3 times in order for it to be able to attach to your user account to run. In my case, it automatically picked it up, and so it's added it, the service is started, and I'm good to go. But just be aware that on some distros, you will see that authentication prompt, and that's because it's binding to your user account running in user space. So that's a little bit of a variation, and that prompt can kind of throw people. Otherwise, I do need to open up some ports on my firewall, so I'll do sudo ufw allow 20-tcp. And I'll follow that up with 21. I guess I could have done a range command and saved a little time. I will do that for my passive ports, though. So I'm going to allow 10,000 through 20,000. And that's going to be for TCP. And I could add a comment to remember or whatever, but that's for my passive transfers that happen inside of FTP. Once that's done, I basically got the server installed, running, and I've got my firewall configured, so I'm pretty good to go.
And now that it is up and running, how can we go about configuring it?
All right, this is probably the biggest part where we deviate from a standard configuration. Pure FTPD's configuration is straight up weird. It's just a strange one. The developers, they wanted it to be a little bit more portable, where it was easy to take the configuration and drop it on new servers without a whole lot of hassle. It does have a standard configuration file, but they don't want you to edit it. Let me show you what that looks like. I'm going to go into /etc/pure-ftpd. And if you take a look in there, you'll see pureftpd.conf. That's the main configuration file. And if I edit that, which it will let me, I can go into that file and I can start modifying configuration settings right in here. The configuration settings are really simple. There is a property followed by a value. So here's a property, broken client's compatibility, and then the value is set to no. That compatibility is turned off, right? So everything will be like that. A name on the left and a value on the right. If I want to edit it, I just go through and I put that in here. For example, if I want to enable anonymous communications, then I would come in and say, well, actually, anonymous is on by default. So if I wanted to turn off anonymous communications, well, we could find that in here. It's called no anonymous right here. No anonymous. I could set that to yes, and that would turn off anonymous accounts, kind of almost like a double negative by default. No anonymous set to no means anonymous users are allowed. Well, if I edit it here and reload, that's fine. But if I go to a new server, or if I need to merge configurations, I got to go line by line and find the differences and fix that. That can be a bit of a hassle. And so what they've done is they've set up a system where instead of changing values in the config, there is a subfolder in here called conf. And what you can do is you can create text files in here. where the file name matches the property, and then inside of the file, you put the value. So you can see I've got a file in here that says no anonymous. And if I look inside of it, it just has the word yes. No anonymous is set to yes, and that means right now I am not allowing anonymous communications. And if I want to allow anonymous communications, I need to change that yes to a no. So I can just edit that file. So I'll say sudo edit, no anonymous, and I'll say no to that. And when I save it, that's going to make it where now that setting is set to no. And a lot of people will just kind of automate this using the T command. So you can echo the word no, pipe it into T, and drop it into that file. It's kind of a hassle. It's usually easier to edit the file. But it's a weird way to configure it, but just know that that's kind of different than pretty much any other service that's out there. No anonymous, that's one setting we might want to make. Another one, I might want to set up my passive port ranges. And so I could come in and say echo 10,000 space 20,000, right? Those are the values I want for my passive ports. I'm going to echo that into sudo t /etc /pure-ftpd /conf /passive range, or passive port range. I got to do the right value here. Passive port range. When I do that, it's going to create a file called passive port range, and inside of it has 10,000 space 20,000. So that setting is the same as if I had gone and edited the main configuration file and put it in there. Now when it loads, it will read that, it'll see that it's available, and it'll know that's what I want. So that's kind of how we go about configuring it. It's weird, but once you get used to it, it's not so bad.
Now, is there any way for you to monitor people's access?
Yeah, actually the logging should be turned on by default. Let's check that out. So I've got this value right here, alt log, right? Alt log, it's a little confusing because that stands for alternative logs. So if you want to do something alternative to the default, but what's in there already is the default. If I cat that file, let me cat alt log, I can see it's got one entry in there, which is clf : and then it points to a file, /var/log /pureftpd /transfer.log. That's the default log. It's already created, it's already enabled. But that CLF at the beginning, right? It's just a regular carriage return line feed, simple text log file that we're used to. I'm trying to remember what it stands for. I think it's common log files, what that actually stands for, where each line represents a single log entry, and that's that. But it does actually support more than one style or format of log. So let me edit that. So I'll do a sudo edit alt log. And I can just add more entries to this. If I have more than one type of log I want to output, I can just punch it in here. So maybe I want W3C formatted logging. This is really useful if you have like a security, like centralized logging or a SIEM, and it's expecting log files in a certain format. We can put it in the W3C format and have that. I'll need to specify a destination, and I don't want to use the same file name or I'll have a conflict. So maybe I'll call this one, we'll call it transfer-w3c.log. And it also supports doing one that is optimized for statistics. So I'll call that one stats : /var /log /pure-ftpd /transfer-stats.log. So now it's going to generate 3 different log files of activity on the system in 3 different formats. And so I'm just dropping them all in here. Now, the cool part about this is, in theory, all the stuff that I'm putting in the conf folder, these are the things that I'm modifying on the server. So if I ever want to go to a new server, I just have to copy these files over, and it's got my configuration. And if some of these files already exist in the new server, now I know where there's a conflict. So I know exactly where to look for settings that might bump into each other, and I can fix that. Versus if I just copy a configuration file over, well, I've got to run some kind of comparison on them or something to find it. This makes it a lot easier. That's one of the reasons why they chose to do this. But once I've got that put in place, I do need to restart pure FTP before that will work. So I'll do a sudo systemctl restart pure-ftpd. We'll get that restarted. And then let me connect to the server and transfer something. I'm going to fire up trusty old, what do I want to use today? Let's use FileZilla again. All right, so in FileZilla, I can just get connected to my server. I'm going to punch in the IP 10.222.0.51. I'll use my username to connect so that I'll see it in the log. I'll punch in my super secure password, and I'm going to go ahead and connect. Now, I will get a warning because FTP is using plain text by default, so I'll just have to say okay to that. And it's going to connect. I see my home directory. And maybe I want to copy something down. Let me drop something in, let's see, do I have my downloads folder here? I will copy this file down. So it's going to download. And then once it's downloaded, now I can go and see that in the log. So I'll do a sudo cat /var/log /pureftpd /transfer.log was my default log. And right there, I can see that entry that I've transferred the file. I can see that user dpossess got /home /dpossess /file1.txt. So I can see that activity. It's all stored right there in the logs. And we can make sure that our server is being accessed responsibly.
Now, pure FTPD is supposed to be pretty secure, but FTP is just a plain text protocol. So is there a way that we can make pure FTPD use encryption?
You can, but I'll say the same thing that I said about VS-FTPD, which is while you can make it secure, you generally don't want to, that there are better protocols for that. SFTP, the Secure File Transfer Protocol, uses SSH. You don't even need an FTP server. It does a better job of encrypted file transfers. But if you want the advanced bells and whistles of pure FTP, you want like ratio downloads, then that's where you just need to make it as secure as you can. And so we can bolt on TLS, or Transport Layer Security, to add that functionality. It's just like SSL on a web page. We can make FTP run over that and configure FTPS. The only thing we need is a certificate. We've got to generate a certificate for this. And unlike VS-FTPD, where it used like the default system one, here I'm going to generate a self-signed certificate for us to use. So in order to do this, there's two things I have to set. First off, I need to enable TLS in my configuration. So to do that, we have a simple setting. I'll just say echo 1, and I'm going to sudo t that. And I'm going to drop that in /etc/pure-ftpd/conf/tls. The TLS setting has a few different values. There's 0, which is to not do it. 1 is to make it optional, and 2 is to require it. So if I want to require TLS, I can set that to 2. If I want it to be optional, I just set it to 1. And that's what I'm doing. I'm making it optional on my FTP server. But that setting right there is going to tell it that I want to at least support it and enable TLS. Then I need a certificate. So for that, what I'll do is, let me just switch to my home directory for a moment. And I'm going to do a open SSL REQ. So I'm going to generate a certificate request for a -X509 certificate. I'm going to do -nodes, and that's what's going to let it know that I don't need a passphrase on it, and I'm going to self-sign this one. Then -new key. So I'm generating a key. I'll do RSA:2048. So I'm doing a 2048-bit key. And then -key out. I'm going to output this to a file called pure-ftpd.pem. And then I have to specify -out again for the certificate part. So just the signed certificate. And I'm going to put it in the same file. So it'll be pure-ftpd.pem. PEM files can store the key, the certificate, you can store it all in one. And then last thing, I'll do days. I'll make this one we'll do 2 years, 730 days. So I'll run that. It's going to ask me for my country, my state. So I'll just kind of punch in the values as we need them to be. I'll be IT Pro TV will be my company today. Organization will just be the IT department. The fully qualified name for my FTP server, maybe mine's just lab.itpro.tv. And the email address, people can reach for support. I'll leave that blank. And when it's done, I'll have generated that PEM file. Now, I called it pure-ftpd.pem. I did that on purpose because that's what the default configuration is looking for. If I name it anything else, I have to go and modify the config for it. So it's better to just use the standard name. I need to move it into the right spot. So I'll do a sudo cp pure-ftpd.pem. I'm going to copy that to /etc/ssl/private. And, whoops, I had to spell CP right. Apparently, I do not know how to do that. There we go. And then I need to change its permissions a little bit. I'll do a sudo chmod 600. I need it to not have write permissions on it. And I will assign that to /etc/ssl/private. slash pure ftpd.pem, and I left the hyphen out, so let me get that in there. There we go. Once we've got that certificate with the right permissions and we've got it in the right place, now we just have to restart pure FTP. So I'll do a sudo systemctl restart pure-ftpd. That'll restart it up, and now I should be able to connect and actually get a secure connection this time. So let me disconnect from the server, and this time let me create a site. Or actually, I've got my site left over from last time. I'm sure it'll love the different certificate. So let me just run that through. And this time when it connects, sure enough, it sees a certificate. And it's asking me, do I trust it? And I can see all the values that I just put in. I'll trust it and say OK. And now I connect up and I can see TLS connection established. This is now an encrypted connection to my FTP server.
Well, this was a great introduction to pure FTPD and some of its features. We got to look at the installation process and configuring it, and we were also able to look at enabling some of the security features as well. But that's all we've got time for in this episode. Stick around because we've got more LPIC coming up. Thanks so much for watching. We'll see you next time.
Thank you for watching IT Pro TV.
SSH is a pretty secure protocol by default, but did you know you can make it even more secure? Stick around and we'll show you how.
You're watching IT Pro TV.
Welcome back. I'm your host, Sophie, here with Dawn for more LPIC, and this episode is all about restricting access to SSH. So can you give us kind of a 10,000-foot view of what we're going to talk about?
Sure. SSH, like you said, it's pretty secure, but there are things we can do to improve the security in it. And so this episode, we're going to run through a few things. We'll look at some default settings and ways that we can strengthen them. We'll see how we can restrict the amount of users that are able to even use SSH to get in, and specifically look at the root user account and how we can protect that. We'll also cover one extra technology called TCP wrappers, which are on the exam. Not used so much in real life land anymore, but still a useful thing to learn, especially as you get ready for the exam. So that's what we've got coming up here in this episode.
So just to reiterate once again, SSH is a secure protocol, so we know that. So why would we need to restrict access to it?
All right, well, some Linux distros, if they're designed as workstations, may not have SSH installed by default, in which case, that's about as secure as you can get. Just don't install it, right? But if you've installed a server-based distro, they almost always have SSH enabled by default. I'm on an Ubuntu 20.04 server, and it had SSH enabled by default. So I can just log in, and off we go. That idea right there is to make it easy to administer. You bring up a server, you can jump in and administer it right away. But there's some kind of negative caveats to that. First off, any valid user on that system is allowed to SSH in. So we're kind of opening it up for remote access. People can get connected if they have an account. Now, that assumes I've created an account. So the bigger problem there is if somebody's trying to brute force the accounts. Well, to brute force an account, you need the name and the password, or you're trying to guess the password. Well, there is one common account on every Linux system called root. So an attacker knows the root user exists, there's a name, now they can start brute forcing the passwords. And a lot of distros don't have the most secure SSH configuration put in place, which means they're susceptible to brute force attacks. So that's something we want to be really careful with, and we want to try and secure SSH to protect ourselves if we can. Also, they'll usually create firewall rules that are a little overly broad. They'll allow anyone in the entire planet to connect with SSH. We might want to fine-tune that a little bit and say, you know what, how about just my local network, not the whole planet? You have to anticipate where you're going to be remoting in from. So these are all little things that are simple to adjust if we just take the time to do it. If you always work with one distro, you begin to learn the defaults. You know what you need to change and what you don't. Maybe your distro is just secure inherently and you don't have to do any of this stuff. But I find it's a good practice to remember each of these settings so that when I go to a Linux system, I don't care what distro it is, I can quickly skim through and see, is it configured the way that I need to meet my security requirements?
So let's start with something simple. How can we control which users are allowed to use SSH?
All right, well, that's an easy one because it is just right in SSHD's configuration. So let's take a look at what that looks like. I'm on my server, and I'll just do a quick sudo edit of /etc/SSH. Oh, actually, hang on. Let me show you something first before I go too far. Let me browse into /etc/SSH. When you look inside of that folder, you'll see a lot of files. There's a lot of stuff in here. And the main file I care about is this guy right here, sshd_config. That's the SSH daemons configuration. There is another one, SSH_config. That's the client. I'm not worried about the client here. I'm worried about the server, SSHD_config. Now, I could edit that file and start modifying things. However, there are some scenarios where when SSH gets updated, it might overwrite that file and I would lose my changes. It also makes it a little difficult if I want to merge changes to another system. So what they recommend is instead of making changes in that file, you create your own configuration file and put it under sshd_config.d. That's a directory that's included in the main configuration. So when I edit the main configuration here, I'll do a sudo edit of sshd_config. When I look at this, I could make my changes right here, but see this first line? Include /etc/ssh/sshd_config.d/star.conf. Anything that's in that subfolder that ends in .conf is going to get included, right? So I'm not going to make any changes here, but this is where I can see my default configuration and what's in place. All these lines are commented out because they're just showing me the default. I would uncomment and change it to what I wanted it to be if I wanted to deviate from the default settings. So that's all kind of laid out right in here. But I'm going to go into that subdirectory, and in here, I'm going to create a new file. So I'll just create a file. I'll say sudo edit, and I'm going to call mine hardened.conf. All right. You can name it whatever you want. It doesn't have to be, it has to end in .conf if it's going to be included. I generally call it hardened because this is just something that I kind of do as a matter of fact. Like anytime I touch a Linux distro, this is a file that I create, so I've kind of gotten used to it. But again, you can name it whatever you want. If I want to restrict the users, back to Sophie's original question here, basically I can use a simple command. I can say allow users, and then specify the users I want to allow to use the system. I want to use it, right? My user account is dpossett, so I'll punch in dpossett. If Sophie had an account, I might create, I'll do space Sophie, and so on. Just, whoever it is that I'm adding, I put them in right here. I might have 50 user accounts on the server, but I only want me to be able to connect in. So I just put myself in the list. And I can do the same thing with groups. I can do another line and say allow groups. And then I would just say group 1, group 2, maybe admins, whatever it is, specifying each group that I want to allow access. If somebody's not in this list, they won't be allowed to use SSH. So if somebody tries to brute force, the moment they put in that username, it just disconnects. Nope, that user's not allowed to connect. And that's a great way to kind of restrict this down and limit who's able to get into the system.
Now that allow users setting, does that apply to the root user as well?
It doesn't, and it's a good question because I have not included the root user here, right? So if let me get rid of some of this stuff. If I came in here and said allow users dpossess root, right? Well, that would obviously allow the root user. But if I take that out and just say allow users dpossess, the root user is still allowed. The root user actually has their own special setting, a separate one, and it is permit root login. And then this can be set to yes or no. I'm going to set mine to no, which means the root user is not allowed to use SSH. And that's what we want. I should be logging in as me, regular user, and then I can use the sudo command to execute things as root if I need to. You should never log in as the root user unless things have gone really, really bad and you're on the local machine. You're on the local console and you've got to fix something. 99.99% of the time, you should be logging in as yourself and using sudo or elevating your privileges a different way, not logging in as root. So that's why it has its own setting here. And I can just say permit root login, no. And so now that's going to disable that. The root user can still log in locally, but cannot use SSH. So that's how we kind of cordon off that user.
So what about TCP wrappers? I know that we saw them in another episode, but we can use those here as well. Is that right?
Yeah, I mentioned how a lot of SSH servers will accept connections from anywhere on the planet. Well, with TCP wrappers, we can get a little more restrictive. We can say, here's the IP addresses I want to allow to be able to connect. And so we can get a little more aggressive. Now, I'll be honest with you, TCP wrappers are kind of an older technology, and I prefer to use my firewalls to do this. In a firewall, you can create a rule and dictate who's allowed to get to TCP port 22. That's SSH, right? So I can limit things and go that route. But if we want to do it in TCP wrappers, I can show you how to do it. Now, TCP wrappers are a separate thing from SSH. So I'm going to get out of this configuration. So I'll save that. So that is set the way I want it now. DPZ is allowed to connect, root is not, nobody else is allowed. I'm the only one who can SSH. Then I'm going to do sudo edit /etc/hosts.allow. Host.allow is a list of people who are allowed to access certain services. And then I also have host.deny, which is a list of people I want to deny access to services, right? Normally, we just put people in host.allow and we call it a day, but it's up to you how you want to go about that configuration. These files might not exist on your system, but they are supported. That just means you need to create it. It'll be empty, and then you populate it with values. So I'll go into host.allow, and mine's empty, but at least it's got some documentation in there. I'm going to add an entry in here, and maybe I just want my local network to be able to connect. So I could say SSHD space colon space, and then the IPs that are allowed to connect. In my case, I'm going to say local, comma. I'm going to allow connections from the local server if I SSH into myself. I would do that for testing or if I'm running tmux or something like that. So I'll add local. And then 10.222.0. And I'm just going to stop right there, right? It matches just as a plain text match. So it'll look for any IP that starts with 10.222.0. And that's it. So I don't have to do a subnet mask or anything. That's my local network. That's what I've defined. That's going to be the people allowed to use SSHD. Now, if I stop right here, I've said I want to allow local networks. That's great. But what about the deny side? If the hosts.deny file doesn't exist, then it's actually going to allow everybody anyway. Like, it's still going to allow. So I need the deny file to give some teeth to this policy. So let me save that. And then I'm going to take hosts.deny this time. And when I edit that, I'm going to add an entry down here at the bottom that says SSHD space colon space all. I'm going to deny everybody. These files are applied in order. So the allow file will happen first, and then the deny file will happen second. So when I log in with a 10.222.0 address, it'll find me in the allow and it'll let me in. Anybody else would not match the allow, and then it would go to the deny file, and it would see that everybody's blocked, and it would deny them and drop them. Now, the nice part about doing it this way is it doesn't require a firewall configuration, right? I don't have to go to IP tables or anywhere else. I just do it from right here. But the negative of doing it this way is that it's easy to forget about, right? People create these files and forget about them and then can't figure out why they're not able to connect because TCP wrappers aren't terribly popular. But they are very efficient. They run as part of the kernel's networking stack. It's looking at these for a lot of applications that tie into the TCP wrapper library. So they are just kind of efficient, and we can certainly use them. And this is the way that it's done.
Now, before we kind of sign off for this episode, are there any other tips you want to share for controlling access to SSH?
I guess just to be complete, I mentioned firewalls. Like if I want to do that same thing with a firewall, let me show you what I would do. I've got UFW on this system, so I'll say sudo UFW allow. And if I just say UFW allow 22/TCP, that's going to allow anybody to connect. And in fact, if I do sudo UFW status, I can see those are the rules that I've already got in place, right? So I need to get rid of those. Oh, wait. I need to get rid of those rules, but I'm SSH'd in, so I don't want to lock myself out here. So I'm going to create my new rules first, and then I'll remove these in a moment. So I'll do sudo UFW allow, and then I can specify from who these connections are coming from. And I'll say 10.222.0.0/24, so I'm going to allow that subnet with protocol TCP to any port 22. So anybody who's coming from a 10.222.0 address that's going to any other address on port 22. I'm going to allow that to come through. That's going to be SSH, but filtered down from my local network. And I could add the loop back in there as well if I wanted to do local. Then I can do a sudo UFW status numbered. And so I can see numbers 1 and 3 are the old rules. Number 2 is my new kind of tighter rule. So I can do a sudo UFW delete 3. We'll get rid of that one, and delete 1. We'll get rid of that one, and I'm still connected, so I have not screwed up too much. But I can see now I've got a much tighter rule here that's saying you've got to be on my local network in order to access SSH. Otherwise, you're not allowed in.
And in this episode, we were able to look at limiting user access to SSH. We looked at controlling the root user as well as using TCP wrappers, which is something we've looked at in a previous episode as well. That's all we've got time for this episode, but don't go away. We've got more LPIC coming up, so stick around and we'll see you next time.
Thank you for watching IT Pro TV.
SSH is secure by default, but can you really trust the keys that it comes with? Stay tuned and we'll show you how to make your own keys that you know you can trust.
You're watching IT Pro TV.
Welcome back. I'm your host, Sophie, here with Dawn for more LPIC 2, and this episode is all about enabling certificate authentication in SSH. So can you give us like the bird's eye view of what we'll talk about in this episode?
Sure. We'll start off just kind of talking a little bit about certificate authentication and why we want it. Then we'll go into the client-side certificates that we use for authenticating users, and we'll wrap up talking about the server-side certificates for authenticating the servers themselves. It's something that's commonly overlooked.
Now, why would I want to use certificate-based authentication when passwords seem to work just fine?
Well, passwords do work fine, but they have certain vulnerabilities associated with them, like brute forcing, or people write them down, you lose them. People can shoulder surf and watch you type them in. So there's all sorts of ways that passwords can be compromised. Certificates are significantly stronger. It's the equivalent of, like, let's say your normal password is 20 characters long. That's a pretty long password, right? Well, when you use a certificate, it's the equivalent of using a password that is thousands of characters long. That's something that's just basically impossible to brute force. Quantum computing, all that madness, maybe you can make it happen, but for most people, it is virtually impenetrable at that point. It's also such a huge number that it's difficult for us to even attempt to try and remember the first part of it. So it's stored as a file, and that makes it something that we're not going to write down, that we're not going to share with others, that we're going to use for our own authentication. It's just more secure all around. The cool part about certificate authentication is once you get it configured, after that, when you connect to a server with SSH, you don't even see a login prompt. You just connect and off you go. That's it. So it's really nice to be able to have that functionality. It makes it easier on you if you just take the extra effort to get it set up in the first place. And that's really why we need to have this episode, is that many servers out there have SSH enabled by default, but they don't have certificate-based authentication enabled by default. And the ones that do are using certificates that were generated by the vendor, and we don't necessarily know if we can trust those, right? Did the vendor do a good job? There have been cases where vendors have distributed the same private key to every customer. So everybody, unbeknownst to them, were using the exact same private key, which meant attackers could unlock their traffic super easy. So that's why it's important for us to take an active part in this and actually get certificate-based authentication configured and use keys that we generated ourselves.
Okay, so how do I go about enabling certificate-based authentication for my account?
It's actually pretty easy, and I'm glad you said that, for my account, right? Because this is something that's actually enabled by the end user. And normally when we say we get the end user to do something, that's when the nightmare begins, right? Because end users can pretty much screw up anything. But in this case, we've actually got some tools that make this a little bit easy. They're going to generate their own certificate. They'll generate their own private key, and then they'll upload their public key to the server to handle the authentication. So let me show you an example here. I'm on an Ubuntu server, and if I do who am I, I'm logged in as user dpossett, right? Now, I did password authentication to get into this server, so I just logged in with a password, and that was that. Well, I want to do certificate-based authentication. So I'm just going to type exit. I'm going to get out of the server, and I'm going to generate some SSH keys. Now, you might already have some SSH keys, and you can reuse them. You can actually use the same key on multiple servers. So now you've got this single certificate that you're using for authentication. That's perfectly fine. If you do, they'll be located in your home directory in a subfolder called .ssh. So I'm going to switch into .ssh and take a look in there. Mine, I don't have any certificates. I do have a known host file, which is just other servers I've connected to. I've got their certificate stored here, but I don't have certificates for myself. If I did, they would show up as ID_RSA and ID_RSA pub. I don't have those, so I don't have any certificates. I need to generate one. So to generate one is really easy. You can just use the SSH-keygen command. Now, don't sudo this, because then you're going to generate certificates for the root user. You need certificates for you. So I'm going to say SSH-keygen, and I'll run that. It's going to go and generate a key pair for me, a public and private key pair, and it's going to ask where to store them. The default is perfect. I see that .ssh folder. I'm just going to press enter. You can apply a passphrase if you want to secure the file further. I'm not going to do that because it's in my home directory, which only I have access to. So I'll leave that as blank, and it's going to generate those files for me. Now, when I look inside of that folder, I can see ID_RSA and ID_RSA.pub. Now, if I want to authenticate against a server for SSH, I need to take my public key and add that to my user profile on the server. Well, that can be a little bit tricky, but we've got a nice little command that can save us some effort. I'm going to get back to my home directory, and I'm going to run ssh-copy-id. This copies my public key and allows me to put it on a server. Now I just tell it the server. I'll say dpossett at 10.222.0.51. My username is dpossett at, and then either the server name or the IP. When I go to connect, it's going to require me to use my password, right? Because all I have is password authentication right now. So I'm going to punch in my password, and then it's going to connect up and it's going to upload my key to the server. So it's uploaded the key, and now I should be able to connect. So if I try, I'll do an SSH dpossett at 10.222.0.51. If certificate-based authentication worked, it won't ask me for a password. The certificate will authenticate me, and I'll connect to the server. And there I am. I'm in on the server. And on the server, if I look in the .ssh folder, right there I've got authorized keys. And if I look at the authorized keys, I'll find in here basically the public key that I just generated. This one right here, see how it's tied to Don's laptop? That's my public key that's been uploaded to the server. And so now when I connect from my laptop, it knows the public key. I match that to my private key, and we're able to get logged in. So not terribly difficult, and now it's up and running.
So now that that certificate is in place, what if I still want to log in with my password? Can I still do that?
You can. It's going to default to logging in with the certificate, right? So as long as your certificate is there, it'll work. But let's say I go to a new computer, and that new computer doesn't have my private key on it. Well, then I can't connect. Well, actually, I can. I can still use the password. The password functionality is still there. Now, I mentioned at the beginning of the episode brute forcing. I've got certificate authentication, so I feel like, oh, I'm all secure. But password authentication is still on. So an attacker could try and brute force my account, and that would be a problem. So what I need to do from here is, if I want to be truly secure, I need to turn off password authentication. And we do that on the server. So let me get back to my server. Oh, I'm in my server. I'm going to go into /etc/ssh/sshd_config.d. And if you watch our last episode, you know we don't want to modify SSHD's main config. We want to create our own config file, and I've got mine hanging out from that last episode. So I'm going to edit that file, which I called mine hardened.conf. And this is where I'm overriding settings in the default SSH configuration. And the one I want to override is I want to say password authentication, and I want to set that to no. And that means I will no longer accept passwords. I will only accept certificate-based authentication. So that's really going to ratchet up that security and make it where brute forcing is not possible. But if I add any more users in the future, I'll have to get them to send me their public key so I can put it in their profile for them to be able to log in, because they won't be able to use passwords to get in. I've disabled it on the system.
Now, you also mentioned server keys. So what do we need to do with those?
All right, so the server does have a key as well. So this is asynchronous encryption that's going on here. And so there's two different sets of keys that come into play. We've seen the client keys, which are all used for getting authenticated and connected. The server keys are used for actually encrypting the data for the session after it's established. And most people never even think twice about these. They just run with the default keys and don't worry about it. But there are keys in place, and we might want to replace them. They're stored in /etc/ssh. If I just pull up a listing of that folder, see all these files here that are ssh_host_something. All right. Well, there's some that end in pub and some that end in key. So there's private keys and public keys. And then ssh_host means this applies to the server. And then the other word that's in there is the cipher that's being used. And some ciphers are stronger than others. You may actually see different ones than I'm seeing here. Your system might be more secure than mine and have less that are listed. Your system might be less secure than mine and have more listed, or have ones that are really old. Like if you see triple DES or 3DES, something like that, you know you're in trouble. That's not a very strong cipher to use. So we can come in and we can change these. Now, even if it is secure, like I'm looking at this list and I don't see any giant red flags, but I didn't make these certificates. Well, when you install Ubuntu, part of the installation process is it generates these certificates. So these are unique to me. But how do I really know that? I could trust the installer, but if this is some Linux distro I haven't worked with before, I don't know if I can trust the installer or not. And if I've cloned a system, if I'm using images, well, those images might all have the same exact keys in them. I don't want to use the same private key across my whole organization. That's going to weaken security. So I want to regenerate all of these certificates so that I know I can trust them. So the first thing I'm going to do, and this is where people start to get a little bit worried, I'm going to delete all these keys. Now, if you don't want to delete them, you could move them off to another folder somewhere, back them up, but I'm going to delete them because I've done this enough time to not worry about it. So I'll do a sudo rm, and I want to remove /etc/ssh/ssh_host_star. Anything that starts with SSH host, I want to get rid of. So when I run that, that's going to toast all of those keys and get them out of there. So they're all gone now, and now I've got no keys. If I restart SSH right now, I'm going to be a sad panda, right? I'm not going to be able to get connected in. There's not going to be a way to set up encryption. So I need to generate new keys before I restart the SSH service. It's not too hard to do it. So what I'll do is I'll say sudo ssh-keygen. That's the same command we use to generate our user keys, right? But this time I'm generating server keys, so there's a little bit more to it. I'll do -q for quiet output, so it doesn't ask me a bunch of questions. I'll do -n to tell it the passphrase that I'm going to use. And like before, I'm not going to use one, so I'll just do double quotes to say no passphrase. -t to tell it the type that I'm generating, and I'm going to generate RSA certificates. And then -b, the bits that I want to use. Now, some of the certificates that we had in place before were 2048-bit. You might have some 1024-bit. I'm going to bump mine up a little higher. I'm going to go to 4096 bits on mine. You don't want to go too high that you break client compatibility, but you don't want to go too low that the system is weak. So I find 4096 is a good middle ground. Then I'll say -f for the file that I'm going to be outputting, and I want this to go into /etc/ssh/ssh_host_RSA_key. And that's the same name that certificate had before. I've increased the bit length of it, and I generated the certificate myself, so I know that I can trust it versus the one that was already there. When I run that, assuming I don't have a typo, that's going to generate the key. I can pull up a listing, and I can see I now have that RSA key in place, so that's good. And you might want to do the same thing, rinse and repeat for other algorithms. Another popular one that I recommend you do, is ed25519. So I'm going to add that one to my list, ed25519. It doesn't need a bit rate because the default is high enough. And then the file that I'm going to output that to, I'll just change RSA to ed25519, and that will match that one. Okay, so now it's going to generate a certificate using that alternate cipher. When I pull up my listing, I now see I have those two sets of keys. So I've got keys. These files existed before, so the configuration knows to look for them. And technically, I could say, hey, I'm done. But it's a good idea to clean up your configuration a bit, to go in and tell it exactly which keys you want to use and to exclude all the other stuff so you don't get errors in your log files. So the last two things I need to do, I'm going to go into my configuration, which was that hardened file. So I will edit that file again. And I'm going to add two more entries here. One is going to be host key /etc/ssh/ssh underscore config, or sorry, SSH underscore host underscore RSA underscore key. So that's going to point it to that RSA one. And then the second one will be the ed25519. So I'll punch that one in. And so basically the same thing, just changing that cipher name like that so that it knows those two keys. Now, if I stop here, again, I'm good, it'll work, but I will get a couple of errors in my log whenever somebody tries to connect and uses other protocols. So it's a good idea to do one more line to reject any protocol or any cipher other than the ones that we've got listed here. Now, this is a lot of typing, and so I'm going to cheat. I've actually got it stored in a text file in my home directory. So it is my, what did I call that thing? Key algorithms there. So I'm going to copy this line and paste it in, but I'll show you what it is here in just a moment. So let me get back into that hardened file, and I'm just going to add this to the very end. So what I'm saying here, this is one really long line, is I'm basically telling the system, here's the host key algorithms that I support. SSH ed25519, that's my preference. That's what I want to do first. And then you'll see some of the other variations that use that same certificate come next. And then RSA is my second place. If I'm using RSA, I want to do SHA-2. I don't want to do SHA-1. That one's been compromised. And I want it to be 256-bit or higher. So you'll see each of those entries, I'm telling it what I want to support. And I'll put this all in the show notes so you don't have to worry about trying to write it down. It's just a really, really incredibly long line. But once all that's in place, now my server is using keys that I generated, my client is using keys that I generated, and I've restricted us down to ciphers that I know are strong and are computationally secure. So this is where we want to be. Now SSH is secured the way that I want it to be.
And lots of great information in this episode on enabling certificate authentication in SSH. Just to recap, in this episode, we got to look at why we might want to use certificate-based authentication because it is a more secure option than just using passwords. And Don showed us how to configure user keys as well as how to configure server keys. Unfortunately, that's all we've got time for in this episode, but stick around. We've got more LPIT coming your way, so we'll see you next time.
Thank you for watching IT Pro TV.
Are you worried about someone brute forcing the passwords on your Linux server? We'll show you how to use fail2ban to stop them in their tracks.
You're watching IT Pro TV.
Welcome back. I'm here with Dawn for more LPIC 2. Today's episode is all about blocking brute force attacks with fail2ban. Can you kind of give us a summary of what we're going to talk about?
Sure, we're going to learn a little bit about what fail2ban is because not everybody's used the service before. Then we're going to see how to get it installed on our system, and we'll run it, get it monitoring, and maybe we'll even trip an alarm or two and see it in action.
Like you said, first things first, what is fail2ban?
All right, so fail2ban is a pretty neat little service that you can run on any Linux box. It runs on Red Hat-based systems as well as Debian-based systems, and it does something really interesting. When somebody tries to log in to any service, if they fail, if they provide a bad password, it generates a log message. And normally, that's it. It's just there's a log message that's created, and off you go. So if you ever look at your logs and you see, like if somebody's trying to brute force you, you'll see tens, hundreds, thousands of failed login attempts as they're going through and guessing passwords, but nothing happens. Maybe in Linux you've set like an account lockout policy where after they try to log in a few times, then they get locked out, but that only works for services that have that built in. What fail2ban does is something a little bit different. Fail2ban will work with any service that generates log messages. And if it sees enough log messages that meet the criteria you set for failed logins, then instead of telling the service to lock somebody out, because not every service can do that, instead it creates a firewall rule. It says, hey, if an IP address is trying to guess passwords, then I'm just going to create a firewall rule and block that person from connecting. And now they can't access any service, and it doesn't matter whether that service supported lockouts or not. We've effectively cut that person out. So that makes fail2ban really powerful. We can use it to protect anything. So you can do SSH, FTP, you can do web access with it, really anything that generates log messages after an authentication attempt, which is pretty much everything.
So how do we install fail2ban?
It's super easy. This one is just one package. You drop it in there, and it's just really one of the easier security tools to work with. So let me show you that process. If I want to get this one installed, the first thing I'm going to do, I'm on an Ubuntu box. So I'm going to say sudo apt install fail2ban. All right, we're changing login failures into bans on the firewall. So that's what we're going to install. And you know, I keep saying firewall rules. It actually has a whole modular plugin system where you can have it take any action you want when there's a failure. Maybe there's something beyond a firewall rule that you want to do, and you can actually enable that. Sky's the limit. It's up to you for customizing it. When I install it, you'll notice it actually does a couple of things. It's dependent on Python 3, and on some servers we don't have Python installed, so it's going to be adding that functionality in. So you'll see a handful of packages go through, but after that's done, you can turn it on by doing sudo systemctl enable -- now fail to ban. That's going to turn it on. So there we go. Now it's up and running, and I've got fail to ban installed.
So how do we configure fail to ban to audit logins?
All right, well, we do have to configure it, but just turning it on like I just did right there, that does nothing. So it's actually not performing any actions right now. We have to go through and tell it what services we want to monitor and protect, and tell it what actions we want to take. So there's a couple of different configuration files that are available that let us do that. When we installed it, a folder was created inside /etc called /etc/fail to ban. And if you go look around in that folder, you'll see a handful of things that are already in there. The main configuration file is called failtoban.conf, and that's the configuration for the daemon itself. And then there's another file in there called jail.conf. The jails, those are what we're creating that are our protected services. So anything defined inside of jail.conf is a protected service. Now, they recommend that you don't edit jail.conf. And the reason is sometimes when you update fail to ban, that file can get overwritten. So if we're going to start configuring it ourselves, we'll create another file called jail.local. And that's where we'll put our local changes, the things that we want. We'll go in that file. But let's take a look at jail.conf first before we do that. So I'm just going to pull up jail.conf. And it's mostly commented out by default, right? So this is not turned on in any major way by default. But right at the beginning here, I can see an example if I wanted to protect something like SSH. So we've got the default setting for it is if somebody violates our login policy, we will ban their IP address for an hour. We don't need to lock them out forever. Usually most brute force attacks are just they're doing like random scans across the internet. It's not really a targeted attack. But here, if we ban them an hour, and then after an hour they try again, they're just gonna get banned for another hour. So they'll only get to try so many passwords every hour, and that's really going to slow them down and usually is enough to thwart a brute force attack. And then you'll see for SSH, here it's saying SSHD enabled equals true. That means, yes, we want to protect SSH. But this is commented out, so it's actually not protecting it. And if I scroll down in the file, you'll see even more things in here, more examples of what you can do, how many times you want to allow somebody to log in, how much time you want to pass between failed logins, other services you might want to protect, and so on. It's all kind of jumbled up in here that you can see. But when we're ready to make our own configuration, we're not going to mess with this. We're going to create a second file called jail.local, and that's where we're going to put our changes in. So whatever we see in here that's what we want, we'll put it in the jail.local file.
So could we look at an example protecting something like SSH?
Sure. So the way I would protect SSH is a little bit different than what they've got in their example, right? So their example just set a ban time and then turned on SSH. But there's a few extra things that we can define when we protect a service. So for example, we can set our ban action. What do we want to happen when a ban occurs? And we also need to make sure that fail to ban even recognizes what our application is that we're trying to protect. If we look in the fail to ban folder, you'll see a few other folders in here like filter.d and jail.d. If you poke around in some of these, you'll find a lot of different stuff. So for example, let's go into jail.d. And, oh, actually, that one is empty. Let's go into filter. There we go. Filter.d is the one I want. So looking in there, I can see a list of all the services that I want to protect. And we'll find SSHD is right here. These are all services that fail to ban knows about. And when I say knows about, I mean it knows when it looks at the log messages what a failed login looks like. If it's some proprietary service, something that I wrote myself, failed to ban doesn't know what log messages I'm going to generate. I would have to come in and create an application profile right here and tell it, here's what a login message looks like when somebody passes, here's what a login message looks like when somebody fails. And that way it's able to track those and identify them. So this is also where we get the name of the service we want to protect, whatever this file happens to be. This one's SSHD, and that's the one that I want. And if we look inside of that file, you'll see a few things in here. You'll see the log parsing logic, so it knows the log messages to look for, and you'll see some of the different actions that it can take. It's nested in here. It's kind of hard to read these files, but you'll see some of the possible activities that we can take, like generating an email and sending that to administrators, or just putting a firewall rule in place. And when I say putting a firewall rule in place, I might be running Firewall D or UFW or straight up IP tables, well, it supports all of those. We just have to tell it which firewall we're using. That's something we didn't really see in that example a moment ago. So if I want to protect SSH, here's the way that I would do it. So first I would do a sudo edit of jail.local. So I'm going to open up that file. It's blank because it's brand new, so I'm creating it. And I'll put in my defaults first. And the defaults, these are settings that will apply to every service. I want to say things like ban time equals 1 hour. I'm good with 1 hour. We could make it longer or shorter. It's up to you and what your comfort level is. I'll say ban action. And for me, if I'm banning somebody, I want it to create a UFW rule. It defaults to creating an IP tables rule, and that's fine if you're using IP tables. But I'm on an Ubuntu box, and it uses the uncomplicated firewall, or UFW. So I want to create a UFW rule, and so I'm going to put that note in there. Otherwise, the rules will be created in IP tables, and I won't see them. They kind of be transparent to me. Then, for the service itself, I just do a square bracket and type the name of the service, which this one is SSHD. And for its settings, well, I don't have to put much. I'll just say enabled equals true. It already knows what SSHD looks like, and so it can go and perform what's defined in that file. I could add other things in here, like what I want the action to be. I could say action equals, and then specify in the action format what they want. And you just have to look at the application file to find out what those actions are. The syntax is a little bit weird. It'll be something like this. If I do % open parentheses, action underscore close parentheses, S, that means create a firewall rule. Pretty intuitive, right? It doesn't actually say that, but that's what it does. Or if I wanted to do a firewall rule and send an email, I would add an MWL to that. Now, how do I know that? Because I have it written down on a note so I can remember, but it's in the sshd.conf file. We can look in there and see the actions and the other information. Also, you can find some of it in the failtoban.conf file. The actual server's conf file has the actions defined there. So you just read through and find what you want. I'm going to leave that off because the default functionality is what I want. So having that right there is actually enough to protect SSH. I'm going to exit out of that so it saves, and the file is not read by default until I restart the service. So I'll just do a sudo systemctl restart fail2ban, and that's going to run, and now my SSH service is being protected from brute force attacks.
And how can we tell for sure that fail2ban is actually running?
There's a few ways. Now, if this is a server that's exposed to the internet, it'll be pretty obvious pretty fast because you're constantly getting brute forced on the internet, especially with something like SSH. Your server will be found within an hour and a half is usually about how long it takes. And then people will start attacking it within 6 hours. It's really, that's just kind of how it is. And if they're attacking your server, fail2ban should be triggering. And we can see it really easy because we'll have some UFW rules get created. If I do sudo UFW status, I can see I've got rules in there that are allowing SSH. I don't have anything else. Well, as people get banned, I'll see their IP addresses show up right here. But because nobody's banned right now, I don't see that, so I don't really know what's working. So there's a few other commands I want to show you. We can do sudo fail2ban-client. So there's a client that's packaged with fail2ban, and I can ask it to show me the status. When I run that, it shows me my current status. I have one jail created, and it's for SSHD. So I know that SSH is being protected. If I had created other jails for FTP or other things, they would all show up here too, and I know they're running. And then if I say sudo fail2ban-client status SSHD, it'll show me the status for that particular jail. And here's where I'd see currently failed or previously failed. I would know if it has been protecting me from people attacking the system. Right now it's all zeros. It hasn't actually done anything. And there's also the log file that it's creating, /var/log/auth.log. That's actually the log file that SSH uses on Linux. So that's already there. And fail2ban is just monitoring that file and looking for failed logins. So all of that's there. I can also use systemctl to pull the status of the service like we've seen in other episodes. I can use journalctl to look for log messages from fail2ban, all different ways. But this, the fail2ban client, that's usually my go-to to make sure that the client is or that the service is actually working.
So we know that it's running, but is there an easy way to kind of test it out and make sure that it works?
Yeah, absolutely. We can trigger it, right? I could do a brute force attack against the server and see what happens. Right now, with the default configuration in Linux, I can just try and log in over and over and over again. I think it gives you 3 tries and then it hangs up, but then you can connect right back again and try 3 more times, then it hangs up, and you just keep doing that over and over again. There's actually utilities. There's one called Hydra that we can use where you can just throw a library of words at it and it'll just run automated and try and get into the system. So I'm going to do that. Before the show, I downloaded a file that has the 10,000 most common passwords. So not just a full dictionary, because that's tons and tons of words, but the 10,000 most common passwords. And if I was going to brute force a server, this is what I'd use, because the odds are I'm going to hit on the right password in that group of 10,000. So I'm going to go over to my desktop, and let me go into my downloads folder, and here's where I've got that kind of 10,000 most popular passwords file. And so you'll see things in here that are lame, like 1, 2, 3, 4, 5, 6, and password, baseball, football, whatever. But there's 10,000 in here, so it's a pretty big file. Then I'm going to feed that into Hydra, and I'm going to point it at my SSH server. Now, I am SSH'd into the server, so I don't want to lock myself out. So I'm going to use a separate IP address to connect in on this so that other IP will get blocked out. So normally I connect to my server on 10.222.0.51. This time I'm going to do 172.16.1.51, just a different IP so I can stay connected. And so if I want to fire off an attack, I can just say Hydra -L, so I'm going to give it a login. Oh, shoot, I just thought of something. My login uses a certificate to connect, right? So it's not going to ask for a password. So I need a different account. Let me jump over to the server. I'm going to whip up a new user real quick. I'll just say sudo add user jdoe, and I'll set his password. Actually, here, I'll use one of the common passwords. We'll use Thunder. Thunder is in the list. And then the full name, this will be John Doe. And there we go. All right, so I've got a user named John Doe, and let me just jump over and make sure that account actually works. I'm going to SSH into, or as jdoe, into 172.16.1.51, and when I run that, it's asking for my password. I provided the right password, I'm in. Okay, so that works. And now I'm going to go back to Hydra, and I'll do Hydra. I'm going to do a login as jdoe. I want to do a timeout of 2 seconds, so when I try a password, it'll wait up to 2 seconds before moving to the next one. It'll judge that the session is timed out eventually. For my passwords, I'll do a $P, and I'm going to feed in that password list that I've got. And then the IP that I'm connecting to, 172.16.1.51. And then lastly, I'm using SSH. Hydra is now going to take that file with 10,000 passwords and just start ramping through them and feeding them against the server. Now, before I actually run that, over on the server, if I look in /var/log, I can see the log files from my system. And fail to ban does have its own log right there, so I can see fail-to-ban.log. And so I'm going to do a sudo tail-f. I'm going to follow that file on my screen, so anything that updates in here, we'll see that log message get generated. So I'm going to leave that running, and back over here, I'm going to fire up Hydra. So here it goes, it's running, it does multi-threading, so it's actually trying many simultaneous connections all at once, and it's trying to log in as John Doe. Now my source IP here is 172.16.1.50, and I'm connecting to the server at .51. So fail to ban should detect these bad logins. It should create a firewall rule that's going to block the .50 address, and that firewall rule should stay in place for an hour. All right, let's jump back over to the server and see what's going on there. I see a lot of log messages being generated, okay? So right here, I can see these are failed logins that are happening, so it's detecting them. And for the first handful, it let them go. It just says, hey, we found a failed login, right? For the first, 6? And then on the 6th one, that triggered a ban. That's where it banned the .50 address. My client is no longer able to connect. If I go over to my client, I'm just going to break out of Hydra. A moment ago, I was able to SSH in as John Doe. Now, if I try and SSH in, connection refused. I don't even get a login prompt. I'm banned. And if I go back to my server, let me get out of the logs. I'll do a sudo ufw status, and I can see a firewall rule in. I didn't put that there. fail to ban did. It's rejecting 172.16.1.50. All traffic from that IP is now being blocked. And if I do a sudo fail to ban -client status, I can see that JL is running. And then if I add SSHD to the end of that, I can see where it's blocked one IP and it's currently blocked, right? So it's got that timer. It's waiting an hour because it will remove that firewall rule in an hour. And I've got my history of it right there. So pretty easy to get it up and running. And now brute forcing is basically impossible against this server.
So one last thing, how do we avoid accidentally locking ourselves out?
It can happen, right? And you don't want to lock yourself out, especially on a remote server. You might have to drive somewhere. I used to work for a company in Seattle, and we had locations in Hawaii. And so you certainly didn't want to lock yourself out when you couldn't even hop in the car to drive there, right? So in those cases, you might want to put a little note in there to whitelist either your management stations or some kind of out-of-band network to allow you to get in. A whitelist is pretty easy to manage inside of fail to ban. Let me go back into my jail.local file. I'll do sudo edit /etc/fail to ban /jail.local. And in my default section up here at the top, I'm just going to add a new little option here, which is ignore IP. And then from here, I can put the IP of my laptop, which is 10.222.0.50, or whatever the other IPs are. I could put them in here. You can do subnets, like a /24, so I could allow my entire network if I wanted. Usually it's best to be pretty specific, but this will make sure that at a minimum that IP will get in there. A lot of people will put in, they'll say, for example, 127.0.0.1/8, like that, to allow loopback access so that if you're on the system and you're SSHing back into it, it'll still be allowed. I don't know, if I'm working remote, then I'm still going to get locked out with that. So it's up to you how you want to configure it. But whitelists are pretty easy to maintain.
I'm glad there's a way to prevent accidentally locking yourself out, because I can tell you right now that is absolutely something I would do. In this episode, we were able to talk about what fail to ban is. We talked about how to install it and configure it. And as Don just demonstrated, we were able to test it out to make sure that it was working correctly. Don't go away. We've got more LPIC coming up next, but that's all for this episode. So we'll see you next time.
Thank you for watching IT Pro TV.
So you're logged into a server and you've got open ports. Do you know which ones they are? Do you know which ports are open on all your servers? Stick around and find out.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in to more of the LPIC One Linux Administrator. In this episode, we're talking about Nmap and NetStat. Don, what are some of the major goals here?
Well, we're going to learn about measuring our attack surface. So we're going to see some local tools like NetStat and SS, and we're going to see some remote tools like Nmap, we will get to it, and see how we can leverage them to monitor the open ports on a server and measure our attack surface.
All right, Don, so I'm logged in locally to the server and I need to figure out what are the open ports. How do we go about doing that?
All right, if I'm just dealing with one server and I'm logged in locally to it, my go-to set of utilities are going to be NetStat and SS. Now remember that NetStat is an older utility and SS is a newer utility that is a replacement for NetStat. Fortunately, the two utilities use the same command line arguments. So if you learn the arguments for one, you've learned them for the other. And basically, what they're designed to do is show you information about your system's network stack. NetStat is short for network statistics. SS is short for socket statistics, and they're going to show us the stats of what's going on our system.
So, Don, we've seen both of those utilities in other episodes. My question would be, what kind of sets them apart given the contents of our current episode?
Sure. So in previous episodes, I used NetStat or SS just to be able to see and verify that some kind of service was running. But if I don't have a specific service to target, I need to modify the way I use those commands. So I want to show you guys some simple command line arguments you can use to really optimize them. Now remember, the arguments are going to be the same for NetStat and SS. So I'm going to show you using SS, but you would just change it to NetStat if you needed to use the older utility. So for me, SS is built into the system. It's already installed, so I can run it. And when I run it, there's a few little options that I like to use. First off is I don't necessarily need to see UDP ports. If you run SS by itself, you see TCP and UDP ports and ICMP and all these users, string, whatevers, just tons and tons of stuff in here. And most of it are not actually network connections. So I just need to see the TCP connections. So I'll usually run SS-T like that. Now, when I run it, I'm only seeing the TCP sessions. That's good. And I'm seeing that it's actually changing some of the protocols into names. It will try and do that with protocols. It'll also try and do it with IPs if it can match up to like the host file or whatever. Sometimes the names get in the way. And so I usually add like an N to it to say no name resolution, just give me the numbers instead. And so now when I run it, you'll see that it's got that where it's showing the numbers. It's kind of an optional thing we don't have to have. But another one that I will do is A. A is important because I'm just seeing sessions that are established, that are actually doing something. But I might be listening on some ports. And by saying A, that means show all of the available sessions, even the ones that aren't doing anything right now. And then lastly, I like to add one more entry, which is P. Show me the process that's holding that port open. I can see on mine that something is holding open port 8009 on my computer, but I don't know what it is. Right? And 8009, that's not a normal port number. I don't know what that is. So I want to know the program. And so I'm going to add P. And just as a mnemonic for you guys, for me, I always remember this as ATP. Like in biology course, they tell you that was the energy for cells. But some people just remember it as TAP or PAT. But TAP, that shows me all the TCP sessions that are active or that are open and the processes that are using them. And so when I run that, now I see port 8009 is open, and I can see that it's Chrome that's doing it. Google Chrome, for some reason, is holding open port 8009, and I legit don't know why. So in this case, I need to go and find out, digging Chrome's documentation and find out what is it doing on port 8009? Is it listening for a Chromecast or something? Why is it? But now I can find out why, and I know the attack surface of my server.
All right, Chrome, now we also know where the memory leak's coming from as well. So, Don, we've been looking at, you're logged in to a single server here, and we kind of teased this up. What if I want to know more about across the network? How would we go, say, testing a remote server?
All right, so in this case, I'm on one server. But if I have 1,000 servers, I'm not going to go and log into each one. That would be crazy talk, right? So instead, I'm going to leverage a utility. There's an open source utility called Nmap. Let me bring up their website. This is nmap.org, and Nmap is just short for Network Mapper. And originally it was designed as a ping sweeper way back in the 1990s, where it could scan across the network pinging systems and give you a list of who responded. Well, in the last 30 years, they have upgraded this utility a ton, and now it can do all sorts of advanced craziness. It can not just ping a system, but then identify the ports that are open, and then it can connect to the ports and get the headers to even tell you the software behind the port. It can give you a ton of information about your network, and it's incredibly useful. Now, if you're on a desktop, I encourage you to go to nmap.org because they have a graphical user interface version, a GUI, that you can load and actually do these scans and get tons of really good information. But on a server, we don't usually have a GUI available. So we're going to run Nmap from the command line. Now, Nmap is not installed on most distros. I'm on Ubuntu right now. If I run Nmap, I can see it's not installed. But it is in almost every repository out there. So getting it installed is just a matter of doing a sudo apt install Nmap or a sudo dnf install Nmap on a Red Hat-based system, and we can get that installed, and now we'll have that Nmap utility available for us and ready to go. The GUI is in some repositories, but not every repo, so you might have to go to the Nmap website to get the GUI, but the command line version is right there, and now we can use it to scan across our whole network to be able to find out what our attack surface looks like.
All right, we're going to keep him honest here, and I want to see how it's done. Don, can we take Nmap for a test drive? And what I mean is, can you show us how we would detect open ports?
Yeah, so Nmap has a ton of options, and well beyond the scope of this show, but I'll show you some common ones. But it does have a default mode. And its default mode is where it'll scan a range of IPs and give you information back. So you don't have to be an Nmap wizard to make use of this. At its basic level, you could just type Nmap followed by a single IP address. I want to scan an IP address. So I know I've got a machine out there at 10.0.222.52. I want to scan it. Nmap and type in the IP. Now, on some Linux distros, they might have sockets secured, and so you might need to use sudo when you run Nmap to be able to do it. On this Ubuntu system, I don't have to. I can just run it this way. And what it's doing is it's jumping in and running an intent scan against that other node and gathering information and bringing it back to me. Now, that's just one node. I'm normally going to scan more nodes, right? And notice how long it's taking. There's a lot of port numbers. Port numbers range from 1 to 65,534. And so it is scanning all of those port numbers to look for what's open. It's taking forever. Well, I know realistically, most of the danger ports that I'm looking at are under 1024, right? Those are the registered ports. So I can get a little more advanced and filter this down. So let me show you a scan that's a little more realistic. I'll say nmap, and then I'm going to specify the port range I want to scan. I'll do -P, and I'm going to scan from 1 through 1024. That's all I want to scan. I don't want to go crazy and scan everything, just those 1,000 ports. That's enough for me. And then I want to scan 10.0.222.50-54. I'm going to scan those 5 hosts right there. I don't want to scan my whole network. You can. I could say 10.0.222.0/24 or 10.0.0.0/16, and it would scan the whole thing. It would take a long time, but it would go through and scan the whole thing. So I'm going to set that up and run it. And this scan, even though I'm scanning more than one IP, is still going to run faster because it's only 1,000 ports for each one. All right. Now, if it still hangs and doesn't get through in a reasonable amount of time, then I might need to sudo. I might need to bump that up. And so just be aware that behavior can be a little bit different. While I'm waiting on that, I'm going to flip over to a Red Hat box and I'm going to run the same thing. So on this one, I'm going to come in and just do that same nmap scan. I'm going to do the -P 1-1024, and I'll punch in my IP range that I want to do, which was 10.0.222.50 through 54, and we'll kind of run that same scan and see how it looks basically identical. Oh, there. See how fast it ran? It ran super fast, and it's already done. But over here, I'm still hung, right? It's still waiting. So that is a good indicator that I need to break out of that and rerun it, but with sudo to have elevated privileges. And there it goes. So it runs. So it wasn't allowed to open up the sockets that it needed to be able to perform that action. So now it scans and I get my information back. I can see that I found 10.0.222.50. I found 10.0.222.52, 2 workstations. And then it's giving me information about them, like the ports that are open. I can see SSH, HTTP, I can see HTTPS 443 right there, and other information that it gathered about those systems.
All right, Don, one of the things I'd like to focus on here for a second is that we can see some of the attributes of the results back. We can see the port, we can see the state, and we can see the service. And it looks like the port, the numerical value, and the service all seem straightforward. Let's focus in on state. What does a port state mean?
All right, so there are a lot of different port states that you'll see. Open and closed are the most common, right? So open means this port is open on that system, people can get to it, and when they get to it, there is software waiting there to talk to you, right? So if I were to connect on port 80, I'm going to get something on 10.0.222.52. So here, let's find out. So I'm going to fire up my web browser. I'll point to HTTP, because I assume it's port 80, right? And I'll point to that IP, which I copied the wrong thing, which was 10.0.222.52. And when I browse to it, I get the Red Hat Enterprise Linux test page, right? So that's a Red Hat server and it's running Apache. Here's the test page. So that's what open means. Open means that port is available to access and there's software listening on the other side of it, right? You'll see I've got closed down here for HTTPS. That means the port is actually open. You can try and connect to it, but there doesn't seem to be any software listening on the other side. Right? So if I were to actually come up here and point to HTTPS instead, right? So I'm trying to connect on port 443, I get the site cannot be reached. I get connection refused. Not that the system didn't exist, not that it didn't respond, that it just actively refused the connection. It wasn't a firewall blocking me though. It's just there wasn't software that was there that was letting me get in there. Now, you can be rejected. You can be filtered. And so if a firewall communicates back and says, no, your traffic's rejected, that's being filtered. And so you may be knocked out from that. There is an unfiltered status that you see every now and then. That's pretty rare. But that means that you got through, but for some reason, the software just didn't respond. Usually that's the result of something like SE Linux or whatever blocking on the back end. So advanced security can cause blocks like that. There's a few others. You might see combinations like closed and then a pipe and then filtered. And what that means is it couldn't tell if it was closed or filtered. So was there no software running or was there a firewall that filtered me but didn't tell me, right? In IP tables, when you block something, you can choose to reject it or drop it. If you drop it, that means you just throw away the bad traffic and ignore it. You don't respond. But if you block it, you stop the bad traffic and you send a message to that person telling them they were blocked, right? And so that's a way we know if we've been filtered. But if we can't tell the difference, then it'll just say closed, pipe, filtered. And that just means it could be either one. We don't know which one it was. So those are some of the different states that you'll see as it comes back. And that helps you to evaluate the system. On my Red Hat box here, if I have port 443 open, but I'm not actually running the web server on it, that's a risk. I need to close that. I don't need that open. So I could jump over to my Red Hat box and see what's going on, right? So I'm going to do a sudo firewall -cmd -- all and look at the firewall. And sure enough, I can see where HTTPS is open on the firewall. Well, if I'm not running a secure web server, I need to close that on the firewall. That reduces the attack surface. I'm not really at risk right now. If there's no software listening on port 443, then who cares if somebody connects on it, right? But what if down the road I'm experimenting, I install a little program and it bonds to port 443? I might not realize that, and it's already open on the firewall. And so now I have this default install of software that's being exposed on that port, and I'm at risk. So best to close anything you're not actually using. So look at this Nmap report. Try and spot anything on here that you're not actively using and go and block that on your firewall, or remove the software that's doing it. You know, if I have Cockpit running, I think it defaults support 9090. And so if I see 9090 on there, but I know I'm not going to be using Cockpit, then I need to go and uninstall Cockpit if I'm not going to use it. Or at a minimum, block it on the firewall so I can access it locally, but not remotely. That's what Nmap does for us.
Don, you've mentioned that Nmap has a ton of advanced functionality, and they've been working on it for 30 years. So I would say in the context of this course, are there any other types of scans that maybe you want our viewers to be aware of?
So on the exam, like the ATP, those three options that I talked about with SS and with Nmap, what we just saw a moment ago, just kind of a simple scan, those are things that you need to have memorized.
Okay.
Right? But in real life land, there's other types of scans that may come in really handy, right? One thing that Nmap does is when it scans, the first thing it does is a ping. So it pings the network to find a host. And if it finds the host, then it goes and does a bigger exploration. But many systems block pings these days, right? Like Windows 10. Windows 10 blocks ping by default. So you could scan a whole network and not see a single Windows 10 machine. Doesn't mean they aren't there. But because the ping failed, Nmap doesn't go on to do the rest of the scan. So we'll normally modify the scan type. If you pull up the man page for Nmap, you'll see that it has a -S option. And the -S lets you specify what scan type there is. And there's all sorts of different ones that are all documented in here. See these -S, capital S, capital U, capital N. Each one's a little bit different, right? So here's TCP SYN connect. It's going to actively try and connect on those ports, not just do a quick test to see if they're open. We can do UDP scans and so on. Each of these has a slightly different purpose. The SYN connect, that's actually the default, right? If I were to type that out, like if I were to go and modify my scan from earlier, I could say -S, capital S, right? That's the default. That's the scan that I just ran a moment ago. But if I want to change it a little bit and do like a TCP connect, I don't want to just know the port's there. I want you to actively connect to the port and see what you get back, right? So let's run that. So now I'm doing a -S, capital T. The scan is going to run. It sees the ports, and see how it's taking longer to run? Now it's found the ports. It's trying to connect to them. It's trying to connect and see what it gets back. And that's going to take it a moment, because if it fails, it's going to retry. And sometimes the retry interval is like 30 seconds. So you just have to wait and be patient. It's going to try these out and see what it can find out. But this is a cool one because it'll be able to return additional information, like potentially, I'm running SSH. What type of SSH server is it? What version of SSH is it running? I'm running a web server. Did the web server provide any header information? Is it Apache? Is it Nginx? You know, give me a little more data. It may return back with that. Now, I do go a little bit different on this one. I'm actually going to break out of that. I'm doing TCP. I could do UDP. I would just put a capital U instead of a capital T. But one thing that I typically do is with an ST like this, is I add a little more to it. I'm going to add a -PN, capital P, capital N. I've already got a lowercase p for port numbers, but I'm going to add that capital P and capital N. And what that does is it puts Nmap into stealth mode. In stealth mode, it says, I'll do a ping sweep, sure. But just because I don't get a ping response back doesn't mean I'm going to assume there's no host there. Maybe they're just blocking pings. And so then it's going to go and start checking the other ports on top of that. This scan is far more intense. It's going to take a lot longer to run. You just start it, you let it run, and it's going to take some time and see what information it can find, and then it's going to give that back to us.
Don, I have a question about if you have a security appliance, just name any security appliance on your network that maybe, intrusion prevention system, could it thwart some of these scan types? Could it not give you the appropriate information back?
Yeah, absolutely. Sure. So there are IPS devices out there, intrusion prevention systems, that will do poisoning for these.
Okay.
So if it sees a scan that's going on, there's EDR, which is like detection and response systems that will, or endpoint detection and response, that will know that a scan is going on and then pass a rule out to all the other nodes saying, hey, here's this scanner, block this IP.
Oh.
And so it's not the most reliable in systems where you have great security in place. In those scenarios, you're better off using NetStat or SS and whatever and going and pulling the information locally because you know nothing on the network is going to block you. But typically, if I'm in a blue team role, right, I'm defending my network, I'll go to my IPS and I'll put an exception in for my scanner node. This scanner is allowed to do the scan, don't block it. But if anybody else scans, yeah, absolutely block them. Don't let it happen.
All right, there you go. Exploring your servers, open ports, and your networks. Don, what are some of the major takeaways for this episode?
All right, well, we learned about how we could use NetStat and SS to pull the local port information on a server and evaluate its attack surface. And then we learned about the Nmap utility that can be found at nmap.org that we can use to scan our entire network and identify what is open on our system so we can then go and tighten up security, close off what we don't need, and make sure our network stays secure. And, I didn't say it, but let me just throw it in right here. Nmap isn't something that we just run one time and we're done. You can run it on routine schedules to make this part of your auditing process to keep your network secure.
All right, ladies and gentlemen, that's all for this episode. I know Don and myself have enjoyed it, but stick around and enjoy more of that exciting content coming up in the LPIC 1 Linux Administrator.
Thank you for watching IT Pro TV.
The internet isn't a trustworthy network, but you can secure your communications with a VPN. So stay tuned to learn about OpenVPN.
You're watching IT Pro TV.
Welcome back. I'm here with Don for more LPIC 2. Today we're going to talk about building a VPN server using OpenVPN. So can you give us an introduction to what we'll be learning in this episode?
Sure. We're going to learn a little bit about what OpenVPN is because this might be your first exposure to it. Then we're going to see how to get it installed on a system to be able to build up an OpenVPN server. So by the end of the episode, we'll have some basic VPN infrastructure set up on a Linux server.
So what do we need to know about the OpenVPN project?
All right, well, like the name implies, it's an open source project to create a virtual private network or VPN service. In the old days, if you wanted a VPN, you had to go to vendors like Cisco or Juniper or somebody like that and purchase what was called a VPN concentrator. So it was a hardware box that was the server end of a VPN tunnel. Well, there's tons of open source technologies that allow us to do encryption and allow us to do it really well. And so it wasn't long before we had an open source project that provided the same functionality for VPNs. And the most popular of those is called OpenVPN. So it's an open source, freely available project that uses other open source technologies like OpenSSL to provide transport layer security, or TLS. And that allows us to create encrypted tunnels across the internet. Now, we create encrypted tunnels all the time. Like when you browse to a secure website, we type HTTPS and off you go, it's secure. You don't need any special client or configuration for that. But VPNs are a lot more advanced. They carry all sorts of different types of traffic, so they're more complex. And what OpenVPN's job is to manage that complexity and to have a way to authenticate the client that's going to connect and use secure encryption keys. So OpenVPN, not only is it creating an encrypted tunnel, but it's managing the public and private key pairs, the user authentication, and the traffic flowing between the client and server to create these secure tunnels. But it's nice to know that we can take pretty much any Linux box and turn it into an OpenVPN server. We just have to get in and get it set up.
So what do we need to install if we want to use OpenVPN?
All right, well, OpenVPN is actually, it can be very, very challenging to get it set up. The service itself is really easy. It's just a package like anything else. Here on my Ubuntu box, if I do a sudo apt info openvpn, that'll find the package right there, and it tells me about OpenVPN and how amazing it is. It's one package. It includes the server and the client piece are in the same package, really the same set of tools. So it's got it all dropped right there, and I could just go and install this one package. That's okay, right? That'll get OpenVPN installed. You can even start it up and it'll run. But in order for OpenVPN to work properly, there is a heck of a lot more to it. First off, we need user authentication. Where are the users coming from? Well, we need to connect it to our Linux database or connect it to an LDAP server or some other kind of directory service. And that kind of thing is actually pretty challenging. Then we've got to manage the certificates. Not only do we need public and private certificates and key pairs, we need a trusted infrastructure. So we need to set up a certificate authority, and we need a way to generate certificate generation or certificate signing requests. We need a way to sign those certificates and return them back to the clients. And we got to get our users to go through the process of doing all that to get the certificates. It's a lot of work. And once that's in place, now our server is done, but we've got to go and kind of repeat the configuration on all the clients. It's a real headache. So while getting the packages installed and up and running is a pretty straightforward thing, it's the configuration that'll kill you with OpenVPN. So a manual configuration like this is pretty challenging.
It does sound like a little bit of a nightmare. So what if we just want a quick and easy OpenVPN server?
All right, well, if you've been looking at the exam objectives, you'll notice where they really focused on the VPN client side of things. It's because they know how difficult it is to get one of these up and going. And the OpenVPN project knows that as well. And that's why they have several scripts that you can use to actually get an OpenVPN server spun up. And if you just want something fast and easy, you can use these scripts. And I'll be honest with you, I use the scripts all the time anyway because I know that'll get everything up and running, and then I can change anything that I need to change. Once it's installed, you've got the configuration files that you can access. So I would not hesitate to use the OpenVPN scripts to go in and get this set up. Now, the way this works is first I'm going to need to download the script to my system, and then I can execute it. Anytime we download a script from the internet, we need to be skeptical, right? That there could potentially be malicious things in there. So we want to be careful with that. So I'm going to download the script and not directly execute it. I'm going to download it so I can review it first. So to do that, I'm just going to get into my home directory. I'll get into my downloads folder so it's nice and clean. I don't have a downloads folder, so I'll just drop it in my home folder. I'll say wget https://get.io/VPN. So that's a shortened URL that points right to one of the configuration scripts. And I'll do a -O. I'm going to output this to openvpn.sh. I'm just going to drop that into a shell script. So it's going to download it, but it didn't run the script. Now I can take a look at that script. Actually, let me vim that one so we get colorization on it. So now I can go through and I can review this and see what it's doing, right? When you download a script, it's possible that it could have been tampered with, creating backdoors and so on, so you want to review through it. But if you look, you'll see first it's detecting the operating system we're running because it's installed differently on Red Hat versus Debian-based systems. So we'll see that. And then it goes through the process of installing the package for the right operating system, generating a certificate authority, generating the first certificate, and actually creating some of the other certificates we need. So really automating the whole process for getting OpenVPN set up. And if you ever want to install OpenVPN by hand, you can actually just follow this script and it's showing you all the steps involved to get a minimal system up and going if you want to run through it. It's just like 60 commands. You don't want to watch that on TV, that's for sure. So let me get out of this. And I'm going to make that script executable. So I'll do chmod +x openvpn.sh, so that's going to make it executable, and then I can run it. It does have to be run as a root user, so that's why it's so important we review it to make sure it's safe. I'll do sudo/openvpn.sh, and we'll run it. All right. My server has 2 IP addresses, so it's asking which one VPN clients will be connecting to. Well, they're going to connect on the 10.222 network, so I'll specify the first address. Then it sees that I'm behind a NAT router. On a normal VPN server, it's going to have a public IP on the internet, right? And so you won't see this question pop up. But because mine is inside, it's asking me what my public address is. Well, I'm just using this in my lab, so I'm going to tell it that 10.222.0.51 is my public address. In real life land, we'd be using our external IP here. Then, which protocol I use? OpenVPN prefers to use UDP, the User Datagram Protocol. Remember that when it comes to the VPN, we don't want to lose packets, right? And TCP would make sure that we retransmit. But you're running TCP for whatever protocol is going over the VPN. So if I'm running TCP in the VPN, and then the VPN itself is doing TCP, now you've got like overload. And so you're doing double the work you need to. So UDP is good enough. although UDP can struggle to get through some firewalls. And so that's why we have an option. We can do TCP, which isn't as performant, or we can do UDP, where we get the best performance. So that's what I'm going to stick with. Either way, it's going to be port 1194 by default, and I can change that to a different port. I've set up some servers where I ran UDP and TCP. UDP on 1194 and TCP on 1195 or something of that nature. It's up to you how you want to configure that. I'm going to stick with the default 1194. Then when a VPN client connects, what DNS server do I want them to use? Do I want them to use whatever resolver I'm currently using on my system or something else? Maybe I'll pick, we'll go Google. And then a name for the first client. Remember, I said one of the challenges of getting this all set up is that we have to generate certificates for the client and a configuration for the client. Well, it's going to generate the first one for me. I just need to give it a name. And the name can be whatever you want. You can call it just about anything. I'm going to call this one Don's-laptop. And then it's going to tell me that the installation is ready to begin, and I'll press enter. And now we're going to see all of those steps start to fall through. It's installing the OpenVPN package, and then it's installing the certificate authority. It's getting it set up to be able to generate certificates, and then it's generating that configuration. And it even tells me, hey, if I want to add new users or remove users, I just run the script again. If I run it again, it's going to see that it's already configured. And so it's offering, do I want to add a new client, revoke an existing client, or just remove OpenVPN altogether? Couldn't be easier, right? This really makes OpenVPN a lot more manageable than what we're used to, and we get up and running. And so just like that, I now have an OpenVPN server that's up and running, and I'm ready for my first client to connect.
Now, do we need to open up ports on our firewall?
So this is actually an interesting one. When I did the install, it said, what port do I want to run on? And I said UDP 1194. Well, I'm running the UFW uncomplicated firewall. And if I run sudo UFW status, I see I've got port 22 open, port 80 open. I don't have port 1194 open, right? Well, when you run the setup, it actually creates an IP tables rule for it, which doesn't show up inside of UFW. So I don't actually have to open it here in UFW. And this is actually one of my complaints with UFW is it doesn't show you every rule you've got on your system. And so it's very easy to overlook rules that are present in IP tables. If I run sudo IP tables-save, that's going to show me the IP tables configuration. And when I look in here, well, I'm going to find a lot of stuff, but somewhere in here, I'll find 1194. In fact, I'm going to run that again. I'm going to pipe that into grep for 1194. There it is. So I can see that it opened up UDP port 1194. It's accepting that traffic. So it's being allowed in. I know a lot of people will go and create a UFW rule for it. That rule never actually gets applied. This rule will take precedence because it's in IP tables. So I don't have to open any ports. It's already set up. But if I needed to, maybe I really just want that to be in UFW, I could go and remove this line from the IP tables config, and then I would just run sudo UFW allow 1194/UDP or /TCP, depending on what I chose, right? So that would open that up. But otherwise, that's what it would take. I don't need to do it because I've already got the IP tables rule.
So how do we verify for sure that OpenVPN is working?
The easiest way to verify is to take a client and connect, which we're going to do in the next episode. But some of the things that we can look at here on the server, the first thing I would do is check my systemctl status. So I'll do sudo systemctl status OpenVPN. The service name is actually a little bit different. So let me type the full thing here. It's OpenVPN-server@server. All right. Remember I mentioned that the OpenVPN package has the client and server in it. So when we install it, we can run it in either mode. So that's why I have to do the @server at the end. If I was running it in client mode, I'd put @client at the end. So when we get to the client episode, you'll see I do it differently there. So it's sudo systemctl status OpenVPN-server@server. And when I run that, you should see that it's active and running. That's what I want to see. And then as I look at the log messages, hopefully we don't see any errors in there. I do see that it had a problem determining whether I was using IPv4 or IPv6, but it probably chose right. It looks like it did because I see the network interface right there. So it's running on my 10.222.0.51 on port 1194. So it's up and running and things are looking good there. If I wasn't certain if it picked the right interface, well, I could check to see whether it created as a virtual interface. There's a virtual interface, which is what the tunnel will use. If it can't map to a physical interface, it won't create the virtual interface. So I can spot that by running IP ADDR, or I'll usually do the -BR to make that brief. So I'm going to pull up the brief listing of my IP addresses, and I had two physical adapters before, ENP0S5 and ENP0S6. Now I have a new adapter called TUN0. That's a tunnel. It's a virtual interface. That's why its status shows as unknown. It's a virtual interface. It's always up, right? So it doesn't really know if it's valid or not. See how I've got the same thing for the loop backup here, unknown? So I expect to see unknown there. And then the IP address, 10.8.0.1. I didn't pick that address. Well, that's the default for OpenVPN. Its default tunnel network is 10.8.0.0/24. If you're going to have more than 254, 253 people connecting, then you might need to bump that up to a larger network. You'll need to edit the server configuration for doing that, or to do that. If we want to modify the server configuration, that all got written into /etc/openvpn/server. And if you look in that folder, you'll find server.conf. That is your OpenVPN server configuration. I'm going to open that up in Vim. And when you read through the configuration, it's not very neat, not very human readable. It's really just a series of commands that are defining how the server is configured. I see the IP it's tied to, the port. If I want to switch from UDP to TCP, I can just come and edit this line right here and change it, restart the OpenVPN service, and now I'm running on the other port. Same thing with IPs, the DHCP options, all the things that were done in the script, we can come through and change them right here. The main thing that we don't want to mess with are these lines right here that are defining our certificate authority, our private key, and our public key. Those are essential for the server to operate, and that's really what the script saved us from having to deal with setting up a certificate infrastructure. But once we've got that, the server looks like it's running. Everything looks good, everything checks out. We just need to connect a client to it to really verify whether or not it's working.
Well, lots of great information about OpenVPN in this episode. We looked a little bit at what the OpenVPN project is. We talked about how to make installation a little more manageable, and we talked about testing the server to make sure that it's working properly, but it sounds like we might get more into that in a future episode. Is that right?
Yeah, you'll want to stay tuned. We've got a whole client episode. We'll get connected to this server, and that'll kind of complete OpenVPN for us.
Well, all right, then don't go away, because we got more on that in the next episode, so we'll see you next time.
Thank you for watching IT Pro TV.
Need to connect to an OpenVPN server from a Linux client? You're in good hands. Stay tuned.
You're watching IT Pro TV.
Welcome back. I'm here with Dawn for more LPIC 2. Today's episode is all about configuring an OpenVPN client. Can you kind of give us an overview of what we'll talk about in this episode?
Sure. You know, we have a VPN server. We need to connect to it. So we can use the OpenVPN client to do that. So in this episode, we'll see how to install the OpenVPN client, how to load our client configuration in, and then actually get connected to a VPN. We'll see a few other tweaks that we can make to the client to change the way that it behaves, but by the end of the episode, we will be connected to an OpenVPN server.
So first things first, what do we need to install in order to connect to an OpenVPN server?
All right, well, for those of you viewers that actually watched our OpenVPN server episode, you know I mentioned there that the package that installs OpenVPN server is the same for the OpenVPN client. It actually installs both at the same time. So we're going to install the same package we used in the other episode, but this time we're doing it on our client, not on the server. So on my client, and I'll jump over to mine. So I'm on the server here. I'm going to open up another tab that's just right here on my laptop. So I'm on Don's laptop, and I can just say sudo apt install OpenVPN. Now, when we did the server, I made the comment about how incredibly complex it is to set up a VPN server. But the VPN client is actually pretty easy. It's not anywhere near as difficult, and so it's pretty straightforward. So this time, we're not going to use a script or anything to automatically configure it. We're going to do the configuration here by hand. So I'll just say sudo apt install OpenVPN. It's going to find it, and oh, I've already got it installed. Now, I didn't install it. This was a clean install of Ubuntu desktop. It was part of their default image. OpenVPN is pretty ubiquitous across Ubuntu installs or distros. When I did the server install, I did a minimal install, so it wasn't there. On the desktop, I did a full GUI install, so the package is already present. But if I do a sudo apt info OpenVPN, It'll find it right there. And notice it's not OpenVPN server, OpenVPN client. It's just one package that has everything that I need right there in it. So now that I've got that installed, or I already did, that's really what I need to go in and get connected.
Now, in the last episode, we created a configuration for the client. So do we need to copy that over?
You do. So when we connect to an OpenVPN server, it does certificate authentication by default. So the server is talking to a root CA to generate a certificate that it's able to use. Well, it has a private key and a public key. It digitally signs the private key, and it's able to use that to generate keys for all the clients that connect. And that means the clients need to trust the server. And for two-way authentication to work, the server has to trust the clients. So there needs to be this level of trust, and that means having certificates to do it. Now, that means I need to get the certificate on here. So when you set up a server, you generate client connection profiles, and we created one for my laptop in that last episode. The configuration profiles by default are saved as a file with an extension of .ovpn, which is just short for OpenVPN. Let me go back over to my server, and we'll find the one that it generated. I'm going to go into /etc/openvpn/client. Now this is on my server, but I'm going into the client folder. And when I look in there, well, if I've generated a VPN client connection, it will show up right in here. So looking at it, I'm actually not seeing mine, which means it must have dropped it in my home folder on the server. So let's go check there. It is not there. There's one last place that it might have dropped it, which is /root, which I am not root. So let me take a look in that. And there it is. Okay, so it dropped it in my root folder. So I've ran it as the root user. I sudoed the command, and that's where that connection profile ended up. So right there, I can see donslaptop.ovpn. That's the configuration that it created on the server. I need to get that to the client. Now, it's just a text file, and it's not even that big of a text file, but it's got the certificates inside of it. Let's take a look at what's in there. I'm just going to do a sudo cat. I had to do sudo because it's in the root folder. /root/don-laptop.ovpn. All right, that's going to output that file. And let's just kind of run through what's in there real quick. I'll scroll to the top of it. So right at the very top, it says, hey, this is a client, right? Not server config. This is a client configuration. It's going to create a tunnel. It's going to use UDP, and it's going to connect to the server's address, 10.222.0.51 on port 1194. These are all of my server settings. And I could modify these if needed, but they're already set correctly because the server generated this profile. And as I scroll down a little bit further, here's where I'm going to find the certificate for the certification authority so that I trust the root CA. And then I've got the certificate that my server is using. And lastly, the key that I'm going to be using from my end. This is different than the private key that's being stored on the server. We need two different key pairs. One where the server has the private key and one where the client has the private key. So that's a part of this configuration file, and it's all right there. And then lastly, we have our TLS key, and it's defined right at the end for any kind of synchronous encryption that we're going to use. Most VPNs will use asynchronous encryption to be able to set up the session and then switch to synchronous because it's more efficient. It has better performance once it's done. Now, I'm just going to copy all of that. So it's just all right here in my terminal buffer. So I can just copy all of that. And like I said, it's just a text file. So I can copy it. And then I'm going to go back to my client. And I'm just going to edit a text file here to put it in. So I will say nano dons-laptop.ovpn. And I will paste all of that in there. So there's that config dropped right into the client. Once I've got that in place, I can save that file. And so now I've got the connection right here, and I can use it right from where it is, but I need to do a few little changes to it. First off, it's got that OVPN file extension. Well, the OVPN client, the OpenVPN client, expects it to actually be a .conf, a configuration. Well, that's just a rename, so I can do an MV donslaptop.ovpn, and I'm going to rename it as donslaptop.conf, and now it's a configuration file. Same file, just different file extension, not a big deal there. Now that it's there, I can leave it right here if I want to specify the path every time, or I can put it into OpenVPN's configuration directory, and that's what I'm going to do. Remember, when I went to the server, I went straight to /etc/openvpn/client. That's where we want our client configuration to be. Well, it's not there because I just copied it in. So I'm going to send it over there. I'll do sudo mv donslaptop.conf. And I'm going to send that to /etc/openvpn/client. And I'll just pull up a quick listing to make sure it made it over there. And it should have. There's really no reason it wouldn't. There it is. And so now I've got the configuration in the right place, and it's pretty much ready to go at that point. Now I've got my client configured, and that's all it takes.
Now, if we have more than one configuration, how does OpenVPN know which one to use?
All right, so when we activate the VPN tunnel from the command line, we have to tell it which configuration to use. Now, you can define one as the default, and you would just rename it to client.conf and put it in /etc/openvpn. I didn't do that. I put mine in the /client subfolder. And that means every time I connect, I have to specify the name of the VPN profile. So if I have 5 different VPNs, each one just has to have a different file name. And then I would specify that when I connect. So let me show you connecting, because we haven't actually connected yet. So I would basically come in and say sudo openvpn -- client, so it knows that I'm running in client mode, not server, -- config, and then I'll point it to the configuration. So I'll say /etc/openvpn /client /donslaptop.conf. So it'll be able to read from that configuration file and bring up the VPN connection. Now I am running sudo for this, right? I have to be an administrator because it's going to create a virtual network interface and get that set up. We could change the permissions to make a regular user do it, but for that type scenario, you'll typically want to use like your network manager. You'll see my network manager up here in the GUI. We can come in and create a VPN profile right there and load in the OpenVPN configuration, and that'll run in user space. But from the command line, I can just run it here by sudoing it. And when I run, that's going to fire up the client. It's going to reach out to the server, connect, and authenticate. And so it knew how to connect based on that configuration file that I fed it. And if I had 10 files, I just tell it which one I want to use, and that's the VPN that I connect to.
So how can we test and make sure that it's working?
Well, you know, when you run it from the command line like I did, it's all right here on the screen. So if there was an error, I would have seen it. The last thing I see here is initialization sequence completed. That means it successfully negotiated the tunnel, and it's up. And if you read through, you'll see all the different things that it did as it went through and created it. But let's just say for a moment that I didn't see any of that. I'm just going to open up another tab here. How do I know my VPN is up? Well, let's look at my interfaces. I'm going to do a IP-BR ADDR, so I'm going to pull up a brief listing of my IP addresses. I had 2 interfaces, ETH0 and ETH1, and I can see I have a third interface now, Tunnel 0. I've got a virtual tunnel, and it's up. It's got an IP address, 10.8.0.2. That's the default subnet for OpenVPN tunnels. The VPN server is 10.8.0.1, and every client that connects gets another address in that same range. So there's a tunnel, and it looks like it's up. Let's see if I can ping across it. I'll ping 10.8.0.1. That's what the server would be, and I can ping it. So that is crossing over the encrypted tunnel between my client and the server. I know that the tunnel is up. So that's a pretty easy way to see that. There's a few other ways. If logging is turned on the server, then when the client connects, it'll generate its own log. In my case, I can see the log right there, so I don't really need it. But if I had logging turned on, I could go into /var/log, and there would be a folder in here called OpenVPN, which I have right here, OpenVPN, but mine's empty. So I would need to go into my server's configuration and set the logging option to be true or turned on, and then it would dump a log file here. That logging is turned off by default because it doesn't want to leave a bunch of remnants for the VPN tunnel. Assuming I don't have logging turned on like that, I can use journalctl to find out what's going on. We can say sudo journalctl, and I'll do -xeu. So I want to see extended information. If something goes off the screen, I want to be able to scroll to see it. And the U, I want a specific unit. And that unit is OpenVPN at client. I want to see what's going on with OpenVPN client. And when I run that, now I can see if there were any errors. They would show up right here, and I'd be able to spot those and kind of see what's going on. It's kind of like when you do a sudo systemctl status of the OpenVPN at client like that to see the status of it. And right now I can see that it exists, but it's not a service, right? So I manually ran it from the command line, so I'm not getting anything back on it right there. But if I had, and there were errors, they'd be showing up inside of the logs right there.
And can we configure OpenVPN to always connect to a particular config, like an always-on configuration?
Yeah, you can, yeah. I don't really use always-on VPNs. There are some people who do, where just the moment they turn their computer on, they want it to immediately jump out and connect to a VPN. I don't use that. But I also don't like to go to the command line and do all this junk to turn on a VPN. So I like to just have a service that I can start and off it goes, right? So I usually configure things a little bit differently. Let me show you what I would do. Not that, I'm always the right person here, but I'll just show you a way to go about this. So let me go back to my screen where I've got my connection up. I'm gonna hit Control-C on my keyboard, and Control-C is going to drop the tunnel. So the tunnel goes down, I see it's exiting, the tunnel is now off. If I do a I'm thinking Cisco now. If I do IP ADDR and take a look, the tunnel 0 or TUN 0 interface is now gone, right? So the tunnel is gone, I'm disconnected. What I'm going to do is I'm going to go into /etc/OpenVPN, and I want to take the Don's laptop profile, and I'm going to move it into this folder and rename it to be the client.conf. Or I could just copy it if I want to have two different ways of accessing it. I'll do that. I'll say sudo cp./client/dons-laptop.conf, and I'm going to copy it into this folder, and I will call it client.conf. That's the default client configuration that OpenVPN is going to look for. So if I tell it to start and I don't give it a configuration at all, that's what it's going to load. So now it knows that's what I want with Don's laptop. Then I can set the service to connect. I can either manually start the service and that'll bring the tunnel up, or I can set it to start at boot, right? If I say sudo systemctl start OpenVPN at client, that right there will cause the client to start, read the default config, and connect to the VPN. So now I just start that service when I want the VPN to be up, and I stop the service, and the VPN goes down. But if I say enable, now every time my computer boots, it's going to try and connect to this VPN, and I can add -- now to say connect right now. So now we're going to have an always-on VPN connection. When I run that, it's going to start the service, and I didn't see any errors, so let me do a systemctl. I thought that was closer in my history, but it wasn't. So I'll do a sudo systemctl status OpenVPN at client. And there we go. I see that it came up. I've got a warning. It's telling me this configuration may cache passwords in memory. I'm okay with that because I'm not using passwords. We're doing certificate-based authentication, so I can ignore that one. But otherwise, I do see that the tunnel came up. If I do a IP ADDR, actually, let me do brief on that one. There we go. I can see TUN 0 is up, and this is now a service. So every time I shut down the computer, the tunnel goes down. When I boot the computer back up, the tunnel comes up. I've got an always-on VPN, or I can start and stop that connection and achieve the same goal. So kind of easy to get that one going. My client's now up and configured, and I'm in business.
Well, in this episode, we were able to look at installing OpenVPN using a client profile. We talked about testing client connectivity, and Don showed us one way that we can automatically connect to a VPN. That's all we've got for this episode, but thanks so much for watching, and we'll see you next time.
Thank you for watching IT Pro TV.